and then somebody says, hey, Earth's flat. Hey, Earth's flat. They say, well, yeah, but I know hey, Earth's lots of people that have been to space.
But it's just flat and gorgeous to see.
And so the Earth is flat.
How do we know the Earth is not flat?
The Earth is flat.
The Earth is flat, and this is a fact.
Remember, the Earth is incredibly flat.
Nothing to do with the flat Earth. Okay.
Talking about the water level, Jose.
Oh, I thought you were talking about hydrostatics. It has nothing to do with the water level.
Yeah, it is the water level, right?
You can't make a horizontal a mile long. It's not going to work.
You can make a water level a mile long.
Correct. I agree with that.
3 level points, and you
3 coplanar points.
Triangle between them, or a straight line.
Level is horizontal.
I agree, level's horizontal.
I did not say that the level is not horizontal.
Jesse Kozlowski is irrelevant.
Like DP, he says, level is a straight line on a horizontal plane.
He's a wise man.
Of your understanding of the world in which you live, then of course the world looks flat.
You're a universal horizontal waterer.
The world looks flat.
Bam! Water levels give you horizontal.
I'm using laws of math and physics to show Earth is flat. The world looks flat.
When we say flat, as just a common parlance way of not saying lots and lots of words, when we say Earth is flat or flat earther, we do mean that you think horizontal is level.
But I love flat earthers.
Do you have a brain injury? Because I did have a brain injury when I was younger. It was fixed though. I had a very, very small aneurysm before I joined the military.
Neil! Obnoxious twat speaking.
Anna, fuck you.
You twat. I gotta say, you're totally blowing my mind right now. You twat.
It's level.
That's what I do.
There are assholes that just talk bollocks all the time.
Horizontal is a plane, level is the curved surface.
Flat is curved.
We don't have time for a meeting of the Flat Earth Society. Axioms of Euclidean geometry stand true for a flat plane, for things that are in 2 dimensions. They do not stand true for anything that has 3 dimensions.
So out of touch with science.
Science doesn't prove anything.
You don't need to be a scientist to know that the Earth is round.
Science doesn't prove things. It's literally not what science does.
They must have been founding members of the Flat Earth Society. They would not have believed that the world was round.
The Earth is flat.
How can a straight line form a circle?
At what point does a horizontal start to bend?
The whole way, all the time, constantly.
If I say that the world is round, and someone else says it's flat,
The Earth is flat, and this is a fact.
that's worth reporting.
I died once.
But you might also want to report on
The Earth is flat.
a bunch of scientific evidence that seems to support the notion that the world is round.
Honestly, science doesn't prove things. That's not what science does. Proof is literally a word that is used for mathematics. The only way you can prove something is with maths.
That's flat. That's flat. That's flat. That's flat. That's flat.
About not believing our senses and things like that. The easiest thing that I can say about that is, if I'm to believe my senses, the world is literally an indistinguishable blur. We have tools that allow us to perceive things better than our senses can. Our senses are actually pretty rubbish and in most cases shouldn't be trusted. It's flat.
So you go more than 100 feet and this gets really, really hard.
They dismiss solar power.
You jackass.
Yes!
They make jokes about biofuel.
Hold on, moron.
They were against raising fuel standards.
You imagine?
I guess they like gas guzzling.
You're one of the dumbest motherfuckers.
They think that's good for our future.
I'm not just being nasty here, right?
We're trying to move towards the future. They want to be stuck in the past.
Listen to me very carefully.
We've heard this kind of thinking
Yeah,
before.
I would rather cheese grate my nipples.
Let me tell you something.
Listen to my words very
If
carefully.
some of these folks were around when Columbus set sail, straight lines can curve.
Listen again.
Straight lines can curve. Parallel lines can intersect.
They must have been founding members of the Flat Earth Society.
The internal angle of the triangle equal more than 180.
I talk about YouTube characters and names. I don't talk about real life shit.
It can only be perfectly horizontal at a single point.
Oh yeah, it's measurable.
Here's a reasonable offer for you. Suck my dick.
And the trouble is, we know he claims to teach us to his children as well.
That's what bugs the crap out of me.
What, teaching that level is horizontal?
Yeah, because that's wrong.
Like that water is level?
No, you teach your child that level is a horizontal plane, which is not true. And the implication of that is that you are teaching your child the earth is flat. The earth is flat. The earth is flat. The earth is flat.
Look, I would bet you both my testicles the earth is a globe.
That's why I bet my nuts is because of 50.
See?
And
that confident was
house.
Brad of 50s offering his nuts up. He thought he'd go along with him.
I think that was some video I was watching.
Yeah,
No
in the
way.
chat. In the chat, I said,
You
I'll
haven't
put my
put
nuts
yours on the line too, have you, Brad?
Yep, they're on the line. They're pretty safe where they're at.
No, the question was, again, I'll state the question again. Make it as simple as I can. Do you think it is possible to have a vertical that is parallel to a horizontal?
Yes.
The word horizontal doesn't mean what you think it means in this.
What do you think it means? It's a straight line or plane at right angles to vertical. That's precisely what it is.
That's how horizontal can be used, but when we're talking about horizons and horizontal across the globe, we're not talking about it as a straight line in that aspect, are we? I mean, that's not the,
I don't know.
the way that
I would. A
definition's
horizontal would definitely be a straight line, at least.
used. Right.
Yeah,
but
I agree with it.
Oh, wait a minute.
There's ways
Grimm's
to-
about to bend it for you. He's about to give you bendizontal, I think.
That's because, Grim, you're envisioning a curve right off the bat.
Grimm's new school.
with it.
Grimm's new school.
Yes.
You guys are old school.
Bev, I agree. Horizontal is a straight line. How do you establish
How
a
long?
straight line?
How long can that horizontal straight line be?
Infinite. How did you establish
So if you go along
straight
that,
line?
if you go along that horizontal line and do a perpendicular to it, you'd be able to call that vertical, right?
No.
Infinitely. Well, vertical
No.
and horizontal are
No,
perpendicular.
I don't.
So how long can you make a horizontal line then?
Infinite.
Right, and all the way along that horizontal line, you could have a perpendicular, and that would be vertical, wouldn't you? Because horizontal
Negative.
and vertical
Negative
are
vertical.
perpendicular. That's one of the rules.
Negative, Bev.
Oh, so now you don't want to have horizontal and vertical being perpendicular.
That's not what I said.
You said negative.
A line can be infinite. It can be horizontal at one point only. That's what we argue
I'll
about.
make a definition then. A horizontal line, how long can that be? Because that was the initial question. How long, as in length, can a horizontal line be? Please, line. Remember, 2 points.
The line is infinite. A line can be infinite. Can be horizontal at one point only. Hard for you to understand.
You think a point can be horizontal?
Listen, all you freaking trolls, listen, you have to stop. Listen, we are no longer talking about horizontal lines. We are talking about horizontal points, okay?
Yeah.
You have to understand that. Get that through your thick fucking heads.
No,
We're
I don't think
talking
you can
about
have
horizontal. We're talking about horizontal points.
And that's
You
what
can't
Grim
have a
was saying.
horizontal point. A point has no parts.
Jeremy,
How does the thing with no parts be horizontal?
Jeremy, stop, listen, Jeremy, stop trolling us, okay? We have to start talking about horizontal points, gentlemen.
Horizontal
Fuck,
lines
man,
and horizontal planes no longer exist. Because if they do...
Yeah, they don't exist.
If they do, it's fucking flat Earth, right? So we have to do away with them, because that's the only way we can now survive, is to do away with horizontal
I know
planes and lines. They're gone.
Be checked, Bev.
Bendizontal, that's the only way forward.
So tell me, Jeremy, if he didn't compare his water level to a straight line, did he prove anything?
Do you understand that you can't have a horizontal point?
No, it was a simple question.
Does Jeremy know what the test is?
I've never even heard of it.
Well, there you go. So, like, why are you asking Jeremy whether he thinks we proved anything?
Advertised and online, so Jeremy must know.
I don't know. I wouldn't presume.
Haven't
I don't think I can remember Jeremy coming in when we were doing it, to be honest.
It wasn't advertised, and Jeremy
I think
does
Jeremy
know.
just has a little bit less like in his voice. You know what I mean? So it's easier to talk to him.
Now, just a simple question, Jeremy. If you didn't compare your water level to a straight line, which was established in a different way than a level, did you prove anything?
How would you establish a straight line?
That's
I have
not
no
on
idea what you
me.
just said.
That's on you. I'm asking Jeremy.
I don't know what you said. Was he eating chips or something?
That's nice, George. That's what Rumpus is doing and how Rumpus is going to work. In that example, do you think Rumpus would be you telling other people to do the moving the things around?
Yeah, I'm not exactly sure how he's going to be doing it. They may have it pre-set up where they've already done that beforehand rather than doing it in real time. Because that takes time. It really, you have to fiddle around with each target, moving up and down, communicating, up a little higher. No, you've gone too high, down a little bit. There, you got it. Stop, that sort of thing. And fiddling around, it takes a while. So he might have it all done beforehand, and the heights of the poles locked down and just show you that they're all lined up through by looking through an auto level. I don't know how he's actually going to do it.
Do you know when he's going to do it, George? Because we've been waiting a while now.
Well, he's working on it. He's been going every weekend now for over the past month. He was just there yesterday or the day before. What was it?
Nice.
Sunday he was there. And so he's been going there. He told me, I was just starting to talk to him when I came on here. And he told me that he got 4 targets set up now. So I don't know all the details because I only talked to him for a couple minutes.
Well, he's got to line all of those targets up in the crosshair.
That's right.
He can definitely see him, can't he?
Well, that's what he said. Yeah, he found a point on the bridge where he can see now all 4 targets, apparently. He had some problems with trees being in the way with viewing some of the targets, but it sounds like he's got that result now.
Right, and he's using an auto level for sighting.
Yes.
Nice. Do you know what sort of scope he's got on it? Magnification?
Yeah, it's I think it's a CTS Burger. It's more of a construction auto level. I think it's like 24 power. It isn't, it's one of the lower powered auto levels, but apparently his targets are big enough that he can still view them and sight them in the auto level. It'd be nice for him to have a higher magnification auto level, but he didn't want to spend a whole lot of money on it, so he bought this one that came up for sale. That was a 24 power, I believe.
What's the difference between that test and a test over the water doing that?
Because you have more distortion. You're down low, shooting across the atmosphere, low to the water. You're not shooting up at an angle.
Okay,
and
what if I'm at 2,000?
Aren't as accurate.
Okay, what if I'm at 2,000 feet, looking down to you on the water?
You can do whatever you want to get elevation changes. What I'm telling you, if you have a mile, you have 1 inch of difference in elevation, you will have water flow, sir.
Okay, what about if the water is level and I take the same shot and there's still slope in that theodolite?
Slope in a theodolite. I don't know what that means. There is
when
no
you look
slope
through
in
theodolite. Wait, so when you look through a theodolite, and that's exactly what a theodolite does for your information.
A
and there's a zero.
is a horizontal. You can take angle
No.
measurement.
Okay, here's the
Yes,
problem.
it does.
Hey, Rukia, an auto level creates a horizontal. Only a horizontal. A theodolite, the slope.
Horizontal.
Okay, the slope, that theodolite has a 0. And it also has numbers that drop down and drop up to create that slope. I'm sorry, maybe you're thinking it wrong. The angle. The slope is what the angle is.
Yeah, and if you have a slope or an angle, and
Okay,
you put
and the
water
theodolite.
angle, you will have water flow.
Yeah, I completely understand that, and I've already explained that's slope elevation. And when you take out elevation, which is what a water level does, because a water level is level on both to both ends. If there's still slope there, then it shows one that means one end is lower than the other. And the only way a water level can remain level but be lower than the other side is due to curvature.
No, that's wrong. To say that is a blatant lie. It could be curvature.
Really?
But the only
Not a
reason
lie.
it's curvature, to say it's
That's
the
not
only
a lie at
reason
all.
is a lie. Yeah. The only reason.
Okay,
the light
then why?
just in there, right?
Then okay, so
What
you
other
can measure.
explanation can
So
you
you
give?
say you're telling me where a theodolite can measure a mile if you're
Not
doing
one
elevation. If you okay, fine. Let's take 20 shots in between. It doesn't matter because I know what you're saying, and yeah, those are offsets. So if I'm doing a 1,000-foot run, I can take shots every 200 feet to get a better, more accurate number.
More
correct?
accurate, right? Yeah, more accurate.
So if you take that theodolite and you to go a mile out into the ocean, and we take 7 shots in between, what's going to create the drop on the other side if we know that's level?
There is no drop.
Okay. If there is, what is that accounted for then?
Well, show me that. Show me where you've done increments.
You just got done telling me. You just got done telling me you.
I've done it. I've set grade stakes for over 2.7 miles.
Okay.
There is no
That's
drop. There's
perfect.
3/4 inch
That's
drop.
perfect. Again, Rakia, that's grade checking, not surveying.
Right, but that's creating a horizontal using grade stakes.
Grade checking has nothing to do with the curvature of Earth.
You're right, because there is no curvature of Earth.
Because it's too small of a scale. The fact that I'm going above grade checker scaling is how I understand you're not getting what I'm saying. You've never done surveying. You've done grade checking.
You're taking a surveying tool that is meant to create angles over long distance, using it to create a horizontal over long distance,
Create or measure. Create or measure.
Measure. But you can create a horizontal plane by taking those measurements.
Okay, and if you take those measurements and you create that horizontal plane or line or segment, whatever you want to call it,
right?
And there is drop on the other end.
If there's drop.
Yes. What would that be accounted for?
Never seen it.
Okay, you haven't seen it because you're still doing small scale grade checking stuff.
No,
but if you
I've never been shown it either.
Okay, I just showed you. If you've done it before, then the explanation I'm giving you should be very clear in your head.
I know I would never, ever take an optical tool and shoot 1 mile for accurate measurement.
I've already said you can take 7 in between.
So you're doing the same thing I'm doing.
Yeah, but on a survey scale, not a grade checker scale.
Yeah,
There's
right.
no difference? Rakia, there's no difference?
Yeah, show me.
Is there difference between
go
a
ahead.
grade checker and surveyor?
Show me the method you use.
Is
to
there a
create
difference?
Sure there is.
I've already told you. I've already explained it. You take one shot at the 0, you take another shot, take another shot, take another shot, and then with all your data points that you've gotten, you plot it out on a fucking piece of paper. When you plot out elevation,
that's moronic.
What?
That's moronic. Now go to the middle.
Oh wait. So now taking numerous shots is moronic.
I'll ponder that.
So taking multiple shots is now moronic. You just have been saying that's the method of doing it.
Looks like Sean left. Oh, Bev is here. But Rakia, you know, there's been videos. You keep saying show me. There's been videos to show the curve where it's been measured with surveying tools. You must have seen these. Yeah, I've posted one.
You mean the one where George shows you the horizon rises above the crosshairs? That one.
Yeah, he showed that. He showed that and
posted the one
described
with zenith angles
as an example.
And they add up to more than 180.
You know, he's the only person I've ever heard say that,
lines.
you know. Fancy that, George. being the only person that I've ever heard say that the horizon rises above the crosshairs.
He didn't say that. He said in severe refractive conditions that things can rise above the horizontal.
So he did say that.
He did say it.
And he described it. He described
even showed
it.
us a picture of us.
Look, here's what you can get during high refractive conditions.
Yeah.
But what about all those other observations he did at like noon, where it was stable and showed curvature?
No, that's just where it's refracted less, still showing refraction.
And showed curvature.
George showed. He showed that over 2.7 miles, he said he got 17 feet of movement in the, call it the horizon rising above the crosshair. I think it's ridiculous. I said that he just didn't know how to set his tills up, but
he got 40 feet over 6 miles.
Yeah.
It wasn't the horizon rising above his eye level. It was things in the distance, but not the horizon. The horizon actually, I mean, his 6 mile observation point is actually like, isn't there trees and stuff behind that?
Yeah, you can see the pictures. You want me to get some more pictures? Some of these. I saved them. They were that good.
Yeah, we were talking about this just yesterday. I think we were talking about it, and he was pretty specific in saying that it wasn't the horizon rising above.
The land obviously doesn't rise at all. It can't do, can it? The land can't rise to be above the crosshairs. Well, that's absolutely ridiculous. Anybody who thinks that.
He's been very detailed and explicit in his explanation, and you're misrepresenting what he says.
I've got pictures.
I don't care what you've got. I've heard that conversation.
Yeah, we know you don't care.
Yeah.
No, I've heard it more than y'all are misrepresenting George. Y'all are misrepresenting George Netchett.
How are we misrepresenting? He said it over and over again. It's an optical effect caused by refraction. I even got him to state why. It's caused by the atmospheric conditions.
Yeah,
but that doesn't disqualify his observation.
You see, look at that. I mean, there's no way he could have adjusted the crosshairs to be in the wrong position in them two pictures, is there?
That was
definitely must be the image that you're looking at, right? And if it's just the image that you're looking at, you can't trust anything that you look at through the crosshairs over that distance, can you? That's ridiculous.
Yes, you can. Yes, you can if you take multiple observations and it's stable. Yeah, you can.
No, you can't. You just shouldn't look over that distance. That's the lesson.
That's according to you.
Yeah, according to the pictures that George has got there too. The pictures that George has shown us.
Yeah, that was late in the day, and he took that intentionally to show you what severe refraction could do.
So how do you know where severe refraction occurs?
Because most of the observations are the top picture. It's just like the black. It's just like the black swan.
It didn't seem to show us any of most of those other pictures. We just got them too.
The videographer that did the black swan, in that same video, he shows you water obstructing the oil rigs.
The black swan.
This is what you normally see.
The black swan's a logical argument, right? Not a picture.
No, it's broken. It's an illogical argument.
No, the black swan is a logical argument, right?
Go ahead and debunk it logically, Left Lane.
Yeah, he talks about the 1.22 times the square root of the observer's height in feet.
Wait, no, wait a minute.
Geometry.
Sorry.
That's the geometry.
No, you're talking about...
He leaves out refraction. He leaves out refraction. He doesn't consider
the logical
refraction.
Statement that QE brought, not the black swan, right? The black swan is just the proof of one thing proves that, right? One sighting of a black swan proves that not all swans are white, right? That's the basic principle of the black swan, right?
Well, that's it, yeah.
Right,
yeah.
So that's not what you're not talking about debunking that, are you?
Yeah, the image is severely refracted, and the argument he makes is flawed.
Oh, you're talking about QE's argument, not the black swan.
Either way you want to do it.
Okay. Do you want to start off with the black swan then? If you do the black swan, debunk the black swan, and then we'll deal with what QE's argument was.
The black swan is an outlier. It's not what you normally see.
Mm-hmm. And the proof of one black swan disproves the statement all swans are white, right?
Yep.
Right. So you can't debunk the black swan as a logical concept, right?
He doesn't use it that way, though. That's
Who's
why the
he?
argument.
Who's he?
QE.
Right. So you aren't talking about the black swan. You're talking specifically about QE's argument, are you?
Yeah, the black swan, as a black swan, is just simply stating that all swans are not white. But that's not the way he uses this image in his argument. He says, "I've got one image that's severely refracted. That means Earth's flat, and that's not accurate."
I don't think that's the way it's laid out, is it?
Yeah, that you're misrepresenting the whole argument.
Yeah, do you know what QE's argument is? Can you recite it out to us? Because that doesn't seem like you know what
I
it is.
can verbatim, but I mean it's been done, and I think it's sort of childish and silly to sit here and quote shit like that. Everybody knows the.
But your interpretation seemed completely wrong with it.
Hey,
right?
Am I part of that everyone, Howard? Am I everyone?
I don't know. Do you not know it?
I'd like Howard to tell us.
I know it well enough that Howard just misrepresented it.
Yeah.
Okay. All right. If Earth is a sphere with a radius of 3959, then the horizon can be no more than 1.22 miles times the square root of the observer's height in feet. And then it goes on. The horizon isn't at 1.22 miles. Therefore, Earth is flat. Yeah.
Well, the Earth is not a sphere, right?
Yeah, but it's a broken argument.
Listen, right. So look, even in your P, you didn't have flat Earth, right? So just stick to the claims of the syllogism. So it's not that the horizon isn't at 1.22 miles, therefore the Earth is flat. It's simply the horizon isn't at 1.22 miles. Right? It's just an observation. It's an observation.
Yeah, I'll agree with that.
Right?
Which is the same thing you just called George's stuff. You called it yourself an observation. Congratulations.
It is an observation. But
yeah, exactly.
It's got a very rich data set attached to it.
Yeah, that shows all the refractions that he assumes there is.
No.
Yes,
the conclusion.
That's exactly what he said it was for in the beginning, was refraction test.
The conclusion of George's observation is Earth is a sphere.
Congratulations. Well, all he actually did was did observations of refraction over water, ice, low down, 12 feet, over 6 miles. And at some point, he got like 40 feet difference.
Yeah, he showed, didn't he? He showed that.
Or he just didn't set his equipment
and he
up.
Explained it. And he explained it.
Or he didn't have his instrument set up properly. One or the other.
Yeah,
it's hard to tell.
I doubt that be the case.
Yeah, I know, because you're all up George's ass. This dude's as senile as an old lamb. He didn't know what 100 miles was the other day.
The way I understand it, it tends to be a logistical problem because he lives he has to drive 2 miles to get there from his home, and so there's a lot of time that's wasted in just getting to and from the spot.
2 miles, eh?
Yeah, well, I guess I don't know what average speeds are there in the UK. For here, a 2-mile drive would basically be about 100 miles, but
good Lord.
Yeah, good lord.
I'd say not setting up the equipment properly is the major cause myself. Because, like I say, I've never heard anybody say that the image rises above the crosshairs. That would be ridiculous to say that, but George said it. He showed us pictures of it. I'd say it's impossible, but George seems to think it is possible.
Teaches all about optical illusions called mirages and other things caused by the atmospheric conditions, and then deny it when it doesn't fit their model. It's ridiculous. It's the same people teaching us.
Right, how many people have you got predicting with when Ranty goes up to Winter Hill with the auto level that's going to appear above the crosshairs? George is putting an outside bet in it, is he? Anyone? Has anyone predicted that? What did you predict, Howard? Have you put your prediction in? I predict Ranty won't go. He won't do it.
I stepped out. I had to unstrap my load. What was your question?
I said, have you predicted what Ranty's going to see? And do you think anyone's going to predict that the image will be above the crosshairs? Like George has said is possible.
I'm not familiar with what he's doing.
You're not familiar with Ranty and the great auto level that Ruhif's buying him?
No, huh?
No. Have you seen that picture where Chaiki puts eye level like halfway up the top of the picture?
No, I haven't. I haven't seen what they're doing on that.
Well, I'm sure I've seen it quite a few times. Ruhif's getting everybody to predict it. I'm surprised he hasn't asked you to make your prediction.
Oh, I haven't spoke to Ruhif.
Nice. What would be your idea of somebody taking an auto level up the top of a mountain? I mean, obviously not to do actual surveying or anything related to surveying, but what other than that, would you reckon the idea is somebody doing that?
Well, I don't know. It's just a telescope with crosshairs in it that shoots out a horizontal line of sight, right?
It shoots out a horizontal line of sight?
Yeah.
That's interesting.
Why is that interesting? Because, I mean, you know that's what it is.
It doesn't actually shoot out like all of the image comes to you, right?
Well, okay.
That's where the crosshairs are, or they're in the auto level. So
yeah.
the entire image comes to your eye.
Yeah. Mm-hmm. Again, everybody knows that, Bev. It's not like it's shooting out a laser beam or something like that, you know? You know what I'm saying?
Well, yeah. You call me a bit pedantic with the words, but shooting something when you're just looking at it. I've heard a lot of people say that. So if the image comes to the auto level rather than the auto level shooting it outwards, then is it dependent on what the image and what happens within the image that you're looking at, what you see at the end result? And what would be your prediction of when you go up in elevation with the crosshairs? Do you think the crosshairs might go up in elevation with you?
Yeah, they go up, and since you know the horizon doesn't rise to eye level, then I would predict the higher you go, the lower what you see in the distance will be.
Yeah, that makes sense. So not like what yours shows, where it actually comes above the crosshairs. Or do you think you'd be able to get that if you adjusted if you had a theodolite and you could adjust the hairs and move them down? Do you reckon you'd be able to get what George shows?
Oh, I don't know.
What do you reckon would be the best way of being able to get the image above the crosshairs?
Well, I guess you could aim the instrument down, which would be, that would be dishonest, wouldn't it?
Yeah. You reckon you could tilt an auto level down like B-Ball said the other day?
I guess you could, but an auto level, I don't think is designed to measure dip angle, is it? I'm not that familiar with them, but I'm thinking that the auto level is just that it's just made to shoot a horizontal line of sight. But the theodolite, isn't it designed to measure angles, dip angles?
Yeah, a dip angle from what?
From your observer position.
From what? You mean like from the apex of the angle?
Yeah, I don't know. The apex of the angle. I don't follow that.
Where those two lines meet, that position.
What two lines?
For the angle that you're measuring. You said dip angle from what? What does the theodolite do to measure a dip?
Well, if you're looking at a line of, if you're looking at a level line of sight, you're reading 0, and if you aim it down, then it's going to measure in arc seconds, right?
Wasn't
how far down you're aiming?
Wasn't Sean just saying to Rakia though about it not establishing a horizontal? It just measures angles from one thing to another.
Yeah, I don't know enough. I don't know enough about it to get into the particulars of it.
Because how would you expect to know where your eye line was?
Well, if it was set up and leveled at its observation point, that would be 0, right?
What would you zero it at? Like an auto level. Like an auto level, you adjust it and it sort of auto levels.
Yeah, levels itself to gravity.
Yeah. Do you reckon that's what a theodolite does?
I reckon.
Wow. Just like an auto level does.
Yeah, the mechanisms and such, I assume they operate similar or the same.
It's a bit of a problem. Because it can't do, can it?
Do what?
Can't do, can it? Do you know
what do you mean?
Do you know how an auto level works? You know why the auto bit of an auto level's there?
Yeah, it's got a little, what do they call it? A compensator or something.
Yeah.
You set the apparatus up, level it, and release it, and it orients to gravity.
Do you think you could have one of those if you were adjusting the angle of the telescope that you're looking at?
Yeah, I don't know.
I wouldn't think so. I mean, I don't know. Sean G's he's the expert, I think. He did disappear, though. I don't know where he went. It's a pity you haven't got anybody to tell you about him. How it works and all of that. But an auto level, I do know, since an auto level is just a tool for establishing the horizontal, it has specialist equipment in it that makes sure it's always horizontal. That's why it's a first order measurement for elevation. The auto level works differently than a theodolite. The auto level just does the horizontal plane and the elevation measurements, and the theodolite measures angles for your horizontal azimuthal and all of that sort of stuff. It's cool. So and when Ranty goes out there, how many people do you reckon have predicted that it'll be above the crosshairs? Has anyone ever predicted that like Blackpool Tower might be above the crosshairs? It's interesting. I don't know why none of you are all excited about it. You've waited for that long on the globe side to get somebody, and now Ranty's over there doing all of the proofs and everything. You're not jealous? I went to Winterhill last week. It's nice up there. Weather's not too good at the minute. I think I'll go out later, do some pictures. Go to Southport, look at the stones. Let's see. I was thinking what we could do. I could do 2 sunsets next to each other, so we can see the difference between the infrared and the normal standard. I didn't mean to stop all the conversation. So how many predictions have we got? How many have we got piled up? I think Ruhif was asking for them, wasn't he? Is it in the experiment bit?
I say Ranty ain't gonna do shit. He ain't gonna do nothing, just talk.
Science It Out's done a prediction.
But that's just me.
Oh, Science It Out's done one that looks like George's. It seems he's calling it the flat case, though. That can't be too good, can it?
How about Rumpus? How's his test going along?
Put this in the
Anybody?
in the general chat. Have a look at this. This doesn't have to. Science It Out has done the flat case, but that doesn't half look like George's picture there at the top, doesn't it? The way that it's all risen above there. It might have been that. Must have been Flat Earth Day when George did that. Maybe. Maybe Science Out might have thought that George had found out when it was Flat Earth Day, when he was taking the pictures. What do you reckon, Howard? Do you reckon the flat Earth could make the the image rise above the crosshairs? Science It Out seems to think it is.
I'm in the middle of unloading, but just a a general question. Say you've got a mountain that's elevation is 3,000 feet taller than your elevation where you stand, and say it's, I don't know, 70 miles off in the distance. You would expect it to decrease in angular size, right? Obviously, but it shouldn't be below eye level, should it?
When you say decrease in angular size, do you mean just get smaller?
Yeah, appear to get smaller with distance, which is perspective.
Yeah, well, like stuff does.
But on a flat plane, even at 500 miles, which you can't see that far, but it still should be above eye level, you know.
I don't know what you mean on a flat plane. What are you talking about?
You know,
it
Bevan,
still should be above eye level. Really?
Yeah, it should. Yeah, on a flat surface, you know, like I said, the 3,000 the mountain is 3,000 feet higher in elevation than you are at 70 miles. That was quick. It's 70 miles. You would think that it would be above eye level.
Nah, I wouldn't. Would you?
Yeah. Oh. Yeah, on a flat plane, it should be. It's simple geometry.
Simple geometry what? What you see?
Hey, Left Lane, you can't get simple geometry out of Bev. It's Mr. Shared Line Segment.
So
right,
there's George. He can answer your questions you had about the image that you posted earlier. He can answer that question.
No problem. No problem. George, you see Science It Out has done, and he said it's a flat case. He's done a prediction.
Of what?
A prediction of what Ranty's going to see when he goes up Winter Hill with the auto level that Ruhif's buying him.
Okay. Winter Hill is what, a high hill above this tower then?
Yeah, it's at a higher elevation. Yeah, Blackpool Tower is
okay
at the seaside, just next to the coast.
Okay.
A base of about 50 odd feet above mean sea level.
About how high above the tower is this hill, or that Ranty will be setting up the auto level?
I don't know. Winter Hill. It's about 1,500 feet, I think. Something about that.
And the tower is close to sea level?
Yeah. Yeah, right.
Okay.
Right at the coast of Blackpool.
All right. So this image that you've posted, I have it at 9:06. That would be what, 3:06 p.m. your time. Is that the one you're looking at?
Yeah, that's the one that Science It Out has done.
Okay. Now what about it?
His flat prediction. See the way he's got the land in the distance?
All right.
above the crosshair. Well, like I was saying to everybody, I've only ever seen, the only person I've ever heard say that is you. And then you got a picture. And it looks similar to your picture, right? With all of the land or whatever above that crosshair.
Well, it all depends upon how far away that land is. How far is that land? I assume you're talking the stuff across the water, which is blue.
The green bit. Yeah, I don't know. I mean, it's his prediction what he's going to see.
Yeah, well, how far away is that land?
I don't know. I presume it's the Isle of Man. Unless he's imagining something else. That'd be about 90,
well, what I'm saying,
about 90 miles away, something like that.
Yeah. Well, okay. First off, is excuse me, I got rough frog in my throat. Geez, hang on a second. I got to take a drink. Just a minute.
No
problem. Okay. Hang on a second. I got to respond to Rumpus here on Skype. Okay. All right. Okay. Yeah, that could be it. I would have to know the distances and stuff, and I don't know if the land itself would be that much above the horizontal. It would depend upon how high that land is and how far away it is. But yeah, it'd kind of look probably something like that. But maybe the land wouldn't be taking up so much.
George, don't say that. He's taking the piss. That's his flat. That's what he says. Like if it would be flat, I was taking the piss by saying that flat one looks a lot like the picture that you said you took. So it looks like you're the one that's backing his claim for a flat, right? I don't want you to now confirm that it would be possible too, because it's ridiculous. You're going up a mountain. How are you going to get the image above the crosshairs?
Well, I'm saying it depends upon how far away and how high up that land is. Now, the land could go up above the horizontal, Bev, or the horizon that you're sighting in distance. It just depends upon how high that land is and how far away it is. If it's way far away, then it'll be below the crosshair. It'll be below the horizontal. I see that in Colorado. I mean, when I was out in Colorado and took my auto level up into the mountains where I was a good 1,700 feet above the high plain looking into Kansas, everything was below the crosshair. Now, if there was a mountain there, on the front range of Colorado between my auto level and Kansas, then it would have been above the horizontal. I don't know what you've got here. I'm not familiar with that terrain to know how high those hills are or whatever, I'm saying it's possible. It would depend upon how close that land is and how high that land is. But if it's way far away, then it'll all be below the crosshair.
So would that be your prediction, the one that...
I don't know. I can't...
right.
Bev,
sorry, George.
I'm not familiar with that terrain. I don't know how far away those hills are or how high they are that you're showing above the crosshair there.
So you've not been asked to make your prediction by Ruhif?
No, no. Okay. I haven't looked at it at all.
No problem. I made a prediction that I don't think Ranty's going to go and do it.
Okay.
Do you reckon Ranty will do it?
I don't know why not. I mean, I'm not familiar with the area. It would probably depend upon how much traveling and hiking he would have to do. I mean, I've gone through some pretty nasty stuff to get images and stuff in long drives, but I don't know if Ranty's up to it or not, or whether this is effortless or not,
What would you call the surveying technique of, what do you call it? Sighting? distant
Well,
land
it's not
masses
really a
from
surveying
a high
technique.
elevation.
You're not doing any leveling here. There's no differential leveling going. All you're doing is sighting a horizontal.
So what do you call it?
Sighting a horizontal.
At
That's
elevation.
normal. Not normally what surveyors do. Surveyors are interested in establishing level lines and points of same elevation. They're not just looking through an auto level to see where the horizon or the horizontal is. They're not interested in that.
Right, so what would be the purpose of doing it then?
To see where things are below a tangent line or a horizontal line, so you can calculate or determine drop distances. That's how I use the auto level, is I use to sight targets in the distance, line the targets up so that they line up with the horizontal and vertical crosshair, so that I know that the targets all lie along the same horizontal line, or which would be parallel to a tangent line to the Earth. And that way I guaranteed I have the targets all lined up on a straight line. That's how I use it. I mean, surveyors don't do that sort of thing. They don't use auto levels for that. They use it for establishing level lines and points of equal elevation.
Yeah, a backsight and foresight, so you can keep an elevation.
Yeah, but you're not going to do a backsight foresight here.
So what is it that you were doing to be unable to calculate? Because it doesn't measure angles, does it?
I just told you, Bev.
Mm-hmm.
Here, hang on a second.
You just you're putting a line in there, but you've got nothing to measure to. So where do the calculations
come in? No, there is
in?
Hold on. I'll capture this. I'll put it in Paint, and I'll show you what I do.
Jolly good. Sighting horizontals at elevation.
Yeah, in this case, you're not establishing points of equal elevation or level lines. You're not using it to do differential leveling or anything like that. That's not what's being done here in this case. All you're doing is sighting a horizontal. And to drive the point home, when you're using it in that employing it for that use to establish a horizontal, you don't have a usable range like you do with doing differential leveling. You are not limited by how you're reading a range pole or anything. So this 100 meter, 75 meter to 100 meter useful range does not apply in this condition, in this scenario.
Yeah, because you're not measuring anything, so you've lost.
No, you're not measuring.
You've lost
anything.
the auto level's ability to be as a working tool, right?
All you're doing is establishing a straight line horizontal. All you want to do is see what lines up with the horizontal line set up at the point of observation. That's all you're trying to do. You're not making any measurements. In my case, well, I'll show you here just a second.
Is the purpose of an auto level, though, to give you a base, a frame of reference to measure from?
Is to establish a horizontal, and when you put it in a differential leveling condition, you're establishing a horizontal looking in, doing a backsight and a foresight. You're guaranteed that if you're the same distance from those range poles, that those two horizontals that hit the mark on those two range poles are at the same elevation and are level.
You just use that horizontal as a base mark to measure from, right? That's all an auto level does.
Yes, that's what I use it for.
So when there's no measuring taking place, then...
But you can, well, here, hang on just a second. I'm going to show you here. Alrighty, okay, I'm done here. Hang on, let me post it for you. Putting it in the general chat. Now, let's say this is the way I'm looking at what I'm seeing through the auto level. I put a yellow line there to emphasize the horizontal.
Is that what you'd expect to see? That we're going with that as your prediction?
No, forget about what Ranty's doing and forgetting about Blackpool or Towers or anything. I'm just going to show you something, how I use it, and then you may understand better what Ranty's doing. Is I put a yellow line for the horizontal crosshair because it was hard to see in that green land background. But now I have 3 targets, let's say, that I've set up. Now they're not all at the same distance out. Say the leftmost target is 6 miles away, the middle target is 3 miles away, and the rightmost target is, say, 2 miles away.
Like
and
you've
all
got
I'm
Blackpool
doing,
Tower, and then all the windmills.
Forget it. It is so hard to communicate with you. It always is. I don't know why, but it is.
Are those your 3 targets?
I told you to forget about the land in Blackpool. I told you to forget about the image in there. I didn't have time to erase it. All I'm interested in is the horizontal crosshair and those 3 targets that I put in black.
Oh, those 3. Sorry. Yeah, I see them now. I thought they...
Oh, okay. All right. Sorry. Now, these 3 black targets that I have there, the leftmost target, let's say, is 6 miles away. The middle target, say, is 4 miles away. And the rightmost target is 2 miles away. Okay? We got 2, 4, and 6 miles away. And I'm looking through the auto level. And let's say I have you way in the distance at the targets, and you're adjusting the poles that these targets are on. And we're communicating on the phone. So you first go out to 6 miles. You're standing.
What's that, George?
With this pole, with the 6 mile target, and I'm telling you to raise it up and down until you get it centered on the crosshair. So I tell you to stop at that point. So the leftmost target now is lined up, so the center of that target is in line with the horizontal crosshair. Okay. Then you go to the 4 mile target. We do the same thing. I tell you, move the target up and down, and when that target centers on the horizontal crosshair, I tell you to stop and pin the mast down so it doesn't move. So the target is fixed, so its center is now at the center. The center of the target is lined up with the crosshair, the horizontal crosshair.
It
now
sounds
you
like you're talking about Rumpus's test, right?
Yes, Rumpus is just duplicating what I did.
Okay.
I did this 3 years ago out on a frozen lake. And I also did it last year, but I haven't published that. Now, you go to the 2 mile target, the rightmost target. You go to the mast, I tell you to move it up and down until it gets centered on the horizontal crosshair. So now we have all 3 targets lined up with the horizontal crosshair. So we know they now all lie on the same horizontal line. Now, what I do, where the measurement comes in, is now you and I go to each target and we measure using a steel tape rule. We set the tape rule up at the center of the target and we extend it downward to the surface of water. This is all done over a lake or a canal, however you want to do it. I did it over a lake. Rumpus is doing it over a canal. So now you measure the distance from the center of the target down to the surface of the water for each one of the targets. So we go to the 6 mile target. We set up our tape rule and we extend it so it just touches the surface of the water, and we measure the height above the water to the center of the leftmost target or the 6 mile target. We do the same thing at the 4 mile target. We move there. We extend our tape rule until it just touches the surface of the water. We note the height the distance to the target. That's the height of the target above the surface of the water in the middle target. And we do the same thing for the 2 mile or the rightmost target. And then we look at those distances. Now, if we were on a flat earth and the surface of the water was all on a straight flat plane, those distances we measured from the center of the target to the surface of the water ought to all be the same distances. And so by looking at those distances from the target centers to the surface of the water, since those targets are all lined up now in a straight line, we should be able to tell if there's a slope, if there's a curve, or if it's all just flat.
That's nice, George. That's what Rumpus is doing and how Rumpus is going to work. Would
Yes.
in that example, do you think Rumpus would be you telling other people to do the moving the things around?
Yeah, I'm not exactly sure how he's going to be doing it. They may have it pre-set up where they've already done that beforehand rather than doing it in real time. Because that takes time. It really, you have to fiddle around with each target, moving up and down, communicating, up a little higher. No, you've gone too high, down a little bit. There, you got it. Stop, that sort of thing. And fiddling around, it takes a while. So he might have it all done beforehand and the heights of the poles locked down and just show you that they're all lined up through by looking through an auto level. I don't know how he's actually going to do it.
Do you know when he's going to do it, George? Because we've been waiting a while now.
Well, he's working on it. He's been going every weekend now for over the past month. He was just there yesterday or the day before. What was it? Yeah, Sunday. Sunday he was there. And so he's been going there. He told me, I was just starting to talk to him when I came on here. And he told me that he got 4 targets set up now. So I don't know all the details because I only talked to him for a couple minutes.
Well, he's got to line all of those targets up in the crosshair. Can
That's
he
right.
see?
Yeah.
He can definitely see him, can't he?
Well, that's what he said. Yeah, he found a point on the bridge where he can see now all 4 targets. Apparently, he had some problems with trees being in the way with viewing some of the targets, but it sounds like he's got that resolved now.
Right, and he's using an auto level for sighting.
Yes.
Nice. Do you know what sort of scope he's got on it? Magnification?
Yeah, it's I think it's a CTS Burger. It's more of a construction auto level. I think it's like 24 power. It isn't, it's one of the lower powered auto levels, but apparently his targets are big enough that he can still view them and sight them in the auto level. It'd be nice for him to have a higher magnification auto level, but he didn't want to spend a whole lot of money on it, so he bought this one that came up for sale. That was a 24 power, I believe.
Right.
I've been trying to talk to him about getting me some funding. I'd come out there with all my equipment, my theodolites and auto levels, but a lot of that stuff now got burnt up, but I'm looking at replacing it. But I'd still go out, I'd replace the equipment if they wanted to help fund my trip there.
Do you think it's worth it? I mean, is it that bigger thing?
No, I've never been to England. I'd be using it as a sightseeing. I'd stay in England for a couple of weeks, maybe 2-3 weeks, and go look at Stonehenge. I'd like to go to Scotland. I'd like to tour the country. It wouldn't be just to do that.
Go to Bedford, historic place, right?
And then I'd go around and meet people. I'd probably go up to Blackpool and do my own observations and meet Ranty. I'd like to go to Scotland and meet John Watson and look at his telescope. I'd even probably meet you. I'd probably set up a meeting place in London and have a party and throw a party for the UK people. Come and party down one night.
I don't do that, London. I don't do that.
But that hasn't happened, so I won't be participating.
You're missing out. We said we'll go down there and help him film it, document it. Historic. So he's going for measuring the slope or the slope, yeah.
The drop distances from the targets to the water
of the water
surface.
So
that's the measurement.
You're not
that's
saying
being
that the
made.
horizontal rises up, are you?
No.
No. How do
No,
you know? How
that's
do you
the
know it's
purpose
not?
of using an Bev, that's the purpose of using an auto level. It's really hard to make a mistake. Once it's been calibrated, once you verify its calibration, and you set it up and the compensator releases, there's no bias to it. I mean, that crosshair, that horizontal crosshair is dead nuts on and sighting a horizontal, a straight line horizontal.
But
that's the whole
that's
purpose.
surely old school, that, George, right? Have you
Yes,
not heard?
of course it's old school.
The new school is that you don't actually have a horizontal. There's no such thing as a horizontal line or plane. There's only the horizontal
Oh, stop,
point.
Bev. Come on.
No, Bev, that's
Stop with the
ridiculous.
wordplay.
No, when you set an auto level up at the optics, at the center of the optics of the auto level, what you're seeing, that horizontal, you're looking out at a horizontal plane or a horizontal line, however you want to see it. That yellow line I have in that image establishes a horizontal from the auto level. From that point of where the auto level is set up, you're shooting out a straight line or looking over a flat horizontal plane that goes across, that meets that yellow crosshair. That's what you're saying. It is a horizontal. That's the whole purpose of the auto level.
But they've been telling us it's not horizontal.
Oh God!
It's only
It is
horizontal at the point. That's what they've been telling us. Rumpus told us.
It's the horizontal.
Even you told us that,
relative
George.
to the auto level. The auto level is sitting there and giving you a horizontal from its position.
See, here's the thing, George. Bev thinks horizontal is universal no matter what point you're taking it.
Yeah, I know that.
I think if you
And that's what he's
have a
getting at.
horizontal line or plane, then the entire line or plane is horizontal. Yeah, I
but
do
then
think
if you go to a different position, Bev, and you take a horizontal line or plane from that position, it doesn't have to match up with the first horizontal line that you had.
But in this test, we don't care. I don't care if all horizontals should be parallel or not parallel. It doesn't matter in this case. All we're doing is we're setting up the auto level in one position. Don't move it. This is our holy reference point, and we're just shooting a horizontal. If you want to claim that that horizontal is going to be the same if I set up the auto level somewhere else, I don't care. It doesn't matter to me for this particular test, because the auto level is just set up in one position. We're shooting a horizontal and we line the targets up with that horizontal. If you want to claim that's going to be the same horizontal if I set up 2 miles away, fine, go with it. But I don't care, because we're not setting or moving the auto level at any other position. All we're doing is setting the auto level in one position. We're setting up targets in the distance and we move them up and down so that they all line up with the horizontal line given from this one position. That's all I care about.
Okay, I have a question. Let's say we have a spirit level. Let's say, George, it's 6 foot long spirit level.
Yeah.
Is it level at all points? In other words, the middle and the two ends, are they level?
Technically not, no. Only the center, where the bubble is in the window that you look at. That establishes your level at that point. But technically speaking, if you had a spirit level, say that was 2 miles long in each direction from your bubble, and you hung a plumb line in the middle, it would hang vertical and perpendicular to your spirit level. But if you went out 2 miles, for example, and hung your plumb line, it would not be perpendicular to your spirit level. Actually, in order to detect that difference, you'd really have to go out much more than 2 miles, because the curvature of the Earth and the verticals only change 1 degree every 69 miles. So even for a 2 mile spirit level, you'd never ever be able to detect that the verticals are a little bit different and not perpendicular to the spirit level. That's the problem, because the Earth is so huge.
So that's what we were saying before. You guys think that level is only at one certain point.
No.
You just said,
interpreting.
George,
Level,
you just said as much.
No, I did not. No, I did not. You misinterpreted.
Listen,
Level-
SE. Listen,
Oh,
real
Jesus.
quick. Listen, SE. He completely left your example of a spirit level and went straight to a fucking curved Earth, bro.
Yeah.
He didn't even stay. He couldn't even answer your fucking question about a spirit level. No, the
I
spirit
did.
level.
I did.
No, you
Get this
no,
shit out of
listen.
your ears. Get this
No,
shit out
listen.
of your ears,
Okay,
Travis. I
okay,
did.
great,
Someone
great.
please. I'm talking to Horse.
Listen,
I'm talking
yeah.
to SE Montreal.
And I'm
I'm not
calling your
talking to you,
bullshit out.
Travis.
I'm
Could someone
calling your
please
bullshit out.
mute?
Shut up, George.
Someone please mute Travis so I can finish talking
You
to
can't mute
Montreal.
me, George. You can't mute me,
I
bro. I
want to
gotta
finish
rest.
with, I want to finish with
Let him go.
Montreal. You can talk
Listen.
afterwards. You can talk and give your 2 cents in
did. I let
after
you-
I'm talking to SE
I
Montreal.
let
Quit
you
being
answer.
such a knob.
I've got
Come on,
George's spirit
Travis.
level picture anyway. Haven't we,
fuck,
George?
man?
We've done this.
Travis, quit being so goddamn disrespectful. You're an asshole and you're
I'm
showing
disrespectful.
it. I
You're
want
the
to
one
finish
calling
talking
names.
to Messi Montreal.
You're the triggered one.
Are
You're
you
the
not going
triggered
to
one.
let me talk to Montreal? Are you going to let me speak with Montreal
I
or
let
not?
you speak. Listen, I let you speak, and then
No,
Montreal.
I'm
Yeah.
speaking to Montreal. I will have a conversation
I've put your
with
spirit
you
level
afterwards.
picture in there, George, if you want
Oh
to.
my God.
Jesus.
Let him go, Travis. Let him go.
I
Go
just
ahead,
want you to
George.
know I
All
wasn't.
right,
I wasn't calling
Montreal.
names.
What about your spirit level? Do you claim I didn't answer?
It's not that you didn't answer. You answered it, and then you said you didn't.
I didn't say I didn't.
Okay,
Travis
hold
claimed
on.
I didn't.
Okay, clarify. Let's clarify. I asked you. You have a 6-foot spirit level, and I asked you, is it level in the middle and on either end? And you said no, only in the middle. Am I wrong in that statement?
That is correct. What I said. It is. The level is established at the middle, and all other points on that auto or on that spirit level are not level with the point in the middle. They are slightly above. They are slightly higher in elevation wise than the point in the middle.
Okay, so my next statement, tell me if it's correct or not. You think that level is only on one particular point of that spirit level.
Yes, I guess I'd go with that. Yeah.
Okay, so we have clarity. Okay, thank you, George.
Level. See, when
So
you're
what's your
only
point
talking
from
about
that?
one
How
point,
ridiculous
to
that is,
really
George.
talk about level, you have to talk about more than one point. SE Montreal is level. You're going to have at least 2 points you want to level or have at the same elevation. When you take a spirit level and you set it perpendicular to vertical at the center of the spirit level and say that's going to be the height that I'm going to reference, or that's going to be the level point, then yeah, no point elsewhere on that spirit level will be level with that point or at the same height. But for all practical purposes, for a 6-foot spirit level, the deviation is so slight. The height differences, the level differences along that spirit level are so insignificant for all practical purposes. We say those points are level.
Okay, understood.
Technically,
Okay,
they are
hold on,
not.
George, don't go on. Hold on. Now let's extrapolate this. Let's go to a skating ring, right? We have Now we throw water on that skating ring, right?
Mm-hmm.
Now we want it to be level. Is it your contention that the middle of the skating ring, like a hockey ring where they play professional hockey, is it your contention that the middle of that skating ring is somehow higher than the edges?
No. They're all points will be level. When you put water on a skating rink, it will self-level itself.
Exactly. So how do you figure that?
Can I just interject? I think George misunderstood your question. I think George, what he's saying.
I haven't misunderstood him. He keeps talking about the hump. I know exactly what he's talking about. He doesn't understand that all points on a curved surface can be level or at the same elevation or height.
I think he said level. What he meant is, are they straight with each other?
No, he meant level.
Yeah, he meant straight, George.
I guess I misunderstood.
I did mean straight, yes.
Oh,
straight
okay.
and level.
I'm sorry. You're right, Parmesan. I'm sorry. I apologize.
Yeah, I thought he was trying to trap you in that one.
Yeah, the
Could you announce
spirit
that
level,
one?
George, that you just referred to just before. Were you saying that has a
You have
curve
to be
to
careful.
it, or
You
is
guys
that
have to be-
straight?
Bev, you guys have to be careful when you're speaking with me.
I was
I'm gonna
asking
take you
for
literally on your
clarification,
words.
George.
Not what you mean, but what you say.
Yeah,
Now,
that's why I'm
Montreal,
saying
let's back up.
clarification.
Just a minute. Let's back up and go back to the skating rink. You pour
No.
water on your skating rink, and you let the water settle out. Now, what is your contention about that water?
I'll tell you. You say that the spirit level is only level at the center point. So I put it, is it the same with the skating rink?
Oh, no, well, just clarify just before you go on, Essie, that a spirit level is straight, right? With the bubble
Yes, of
in the
course.
middle. That is a straight thing, George, right? So when Essie's going to continue on here, he's going to be thinking of the straight spirit level and referring that to what he calls level.
Of course, that's
So
obvious.
your question,
yes.
question about the ice rink. Let me just clarify that. Sorry, George. I'll let you answer. Question about the ice rink was you put water on it and you let it freeze. Do you end up with an ice rink that is straight from end to end, or does it have, or is it higher than a straight, not a level?
Correct.
In the middle?
No. Never use the term higher. It is not higher at all points. It's all at the same elevation.
Are you
but
sure,
it
George?
is curved.
Okay. Yeah, so is it straight or is it not straight? I think that's the crux of the question.
Absolutely. Just like your spirit level. Is the skating rink straight or not?
No.
Okay.
So there's a hump in the
curved.
middle. There's a hump in the middle.
It is slightly curved, but that curve is all at the same elevation. You have to understand, the Earth is so huge. When you go 8 inches per mile squared, let's put it in terms of distances and lengths we can understand. So you can
George,
understand.
I don't want to interrupt.
No. Let me finish. This is important. This is important so you can understand the problem here.
Scale negator.
No,
To his
the thing
preach,
is,
buddy.
Montreal. Okay, just a minute. I'm going to turn Travis down. to
Preach
zero,
it, George.
so he
Preach it.
doesn't
You're
bother
making.
me.
You're giving me the
Hang on.
shivers,
Okay.
George.
No, Montreal. The 8 inches per mile squared. If you want to talk about small distances like a 6 foot or a 4 foot spirit level, the curvature of the Earth goes at 287 nano inches per foot squared. So roughly 300 nano inches. That's 0.3 micro inches per foot squared. So if you have a 6 foot auto level, 36 times 0.3 gives us, 10 micro inches. 10 micro inches. 0.01 mils or 0.01 thousandths of an inch. That's the only deviation you're going to have going from the middle of your auto level or of your spirit level over to a length of 3 feet. It's very slight. You can't detect that.
Yeah, you can. Hell, George, we've got. Of course, there's tools that do that.
Okay, well, use those tools. Yes, you've got machinist tools where you do surface grinding and stuff. You could do that. Well, get those tools and verify it for yourself whether what I'm telling you is true or not. Go ahead, go out there, knock yourself out, do it.
Sweet. Yeah.
So this is really
you
like
detect it with the spirit level that you have. It's smaller than the error margin of the spirit level.
Hey,
Yeah,
just runs
spirit
to me
level is
a
a
contradiction.
device. You're going to have to use some very precision equipment to detect these height differences that I claim are there. You can't do it with the spirit level. The spirit level is rather crude. You'd be lucky if you'd be able to set up the tilt to 1/10 of a degree with any sort of a spirit level.
How about a water level? If we were to put one end on the skating ring and one end on the other.
No, because the auto level is just, or the water level does just the same thing as a skating rink. It's like taking two 2x4s 20 foot in length. They both have the same curve to them, and you're trying to say one is straight and comparing it to the other one. And since they have the same curve, you're claiming the other one is straight. No, you can't do that. You can't compare the curve of water as it's leveled out on a skating rink to a water level, because they're both doing the same thing. You're comparing two curved surfaces to one another, or two straight surfaces to one
So
another.
when the Egyptians measured the base of the pyramid using water, they measured a curve there, George? Are you saying the pyramid is not level at either end? It's curved?
I did not say it's not level. Curved is level on the earth.
Oh my God. Hey, Essie, you got to remind George to take me off mute for him, because we don't operate that way in this server.
George, take Travis off mute, please.
No.
Well, that's not fair. I mean, come on. I mean,
well,
he is a mod.
He
I know
has
he's a
to
mod,
learn.
right?
No, I'm putting him in the timeout box for 5 minutes. He has to learn he can't interrupt people.
Okay, tell George I'm going to mute him by this. I'm going to server mute him.
Is
How
there
about
anything
that?
more I can help you with?
He said he's going to server mute him if you don't unmute him, George. So, I mean, he's a mod.
Server
So
mute
it's up
me.
to you.
Server mute me then.
All right, there you go.
You server mute me, I'm going to disappear.
Oh, no, please don't do that.
Don't do that, Travis. Come on.
Listen, just tell him it's not the way we operate, because then you're gonna fuck with everything with having communication. That's all. It's just a matter of you know.
Travis says it's not the way it's done. Unmute him and we'll have a reasonable conversation, George.
I don't have him muted. I just have his audio turned down. I can tell when he's
Okay,
talking.
turn him up a bit, George. Come on, don't be a kid.
Well, is he going to agree not to interrupt people?
Yes, he agreed not to interrupt you, yes.
Okay, fine. All right. He's turned up again.
Okay, we're good, Travis.
Thank you, George. Thank you.
Good morning, Travis.
So, George, because this is a serious disconnect here now. This is like killing the law of non-contradiction. I wanna get this straight.
Oh,
you
stop
say
with
a 6 foot.
non-contradiction laws. Go ahead.
Let me say my thing, and then you can correct me. If I understood you correctly, you say a 6 foot spirit level is only level in the center. Now, how does that compute in your head, George?
That's not. Those are your words. I'm trying to get this across to you. Level. If you're going to talk about level, you have to compare two or more points. Level is meaningless for one point at the center. All I'm saying is if you take your spirit level and you want to reference other points to, say, the center, that's what we use a spirit level for. That bubble in the spirit level is at the center of the spirit level. Now, you use that as a reference point. You set it up to anywhere you want on your bench, on a piece of wood or whatever, and you tilt the two ends until the bubble is centered in the center. Okay, so you're saying all other points now along that level, spirit level, are level with respect to that center point.
By definition,
now, technically, I'm saying that is not the case technically, because the ends are ever so slightly out of level, but you can't see that because the spirit level is so crude, it can't register those differences. Because on a 4 foot spirit level, if I center the bubble in the center, so it's in the center, the end that's 2 foot away will only be let's see here. Let's see, 0.3 micro 4. It'll be 1 micro inch off level.
Okay, understood. Now, if I take that same 6 foot spirit level, which looks straight to me, and I draw a line on a piece of paper, are you saying that line is not level and straight?
I'm saying it's straight. I won't say it's level on the paper.
Okay, I have a question real quick. George, all you're doing right now is math. So are you telling me that there's a standard math that you can apply to every 6 foot spirit level and tell me that every single one of them is calibrated the exact same way, so that your math is telling us that if we bought 100 6 foot spirit levels, they would all have that same mathematical equation that you just monkeyed with?
It's not a mathematical equation that
Yeah, you just
calibrates
crunched
these
numbers.
things.
Yeah, you just crunched numbers.
No,
like
I'm just saying there isn't something you calibrate spirit levels against in a math equation. All I'm doing is figuring out for you how much off level or a height difference there is.
How
Now,
would
if
you know unless you had a physical? How would you know unless
I'm
you had?
telling. Oh, go ahead.
Okay. Again, you when you crunch these numbers, micro inches, blah blah blah, 0.3 or whatever, you're imposing a standard value on this discussion, and I'm saying again that this to me is almost insanity, right? So.
Okay. Fair enough. Travis, fair enough. All I'm telling you is I have a model of the Earth, of the curvature of the Earth, and I can predict for you what the height differences are going to be or how much on level you're going to be. Now, whether you believe me or not is immaterial here. If you don't believe me, you're very welcome to try to test this out for yourself. You're going to have, all I'm trying to impress upon you is you're going to have to get some extremely precision, very fine instrumentation or in order to detect these differences, because I told you with this 4-foot spirit level, if you set up the bubble in this spirit level to be centered so that you say this spirit level is now leveled out, that if you want to find how much out of technically how much the ends are out of level or at a little higher than where level would be, you would need to have something that could register a difference of 1 microinch. That's the problem. And so you are fooled into believing that the spirit level, all along its length, every point on that surface of the spirit level is at the same level. And I'm telling you, they're not. They're slightly out by 1 microinch or less as you get closer to the center of that spirit level. Now, trying to verify whether I'm bullshitting you or telling you the truth is going to be a very difficult thing to do, because how much true level deviation there is from what that spirit level is giving you is so small, it's going to be difficult to measure. You might need some laser interferometers to do this sort of thing. I don't know how else you're going to measure a difference of 1 microinch.
See, Travis, I think what he's basically saying is you have your spirit level, and then at the edges, the Earth will have dropped away ever so slightly because of the
by 1
curvature.
microinch over 2 feet.
And that's what he was calculating, how much the Earth would have dropped away. It's not to do with the actual
Well, that's
spirit
level.
itself.
No, that has to do with level itself.
No, I mean,
the
with
water.
the tool.
George means the actual water, though, don't you, George?
So what?
Water, Earth, same.
Yeah,
union.
water.
It's
Earth.
not like
When I'm
water's
talking about
water
the Earth,
and Earth
I
is
mean,
Earth. They're two different
okay,
things.
that's fine, Bev. Let's just assume that the Earth is a one big water ball. Okay, forget about land. Let's just say it's all one big water ball, so that we know that it's going to all self-level out. There aren't going to be any hills, any valleys, anything. It's going to be a nice, smooth surface. It's a big water ball.
Yeah, the surface of liquid water must curve in that scenario,
yes,
right?
It does. No, it does curve.
Yeah, that's what I said. It must curve. If that's the scenario, water ball, then the surface is a surface of constant curvature.
Yeah. Hold on, I got a phone call.
That's rumpus.
I think George has a landline still.
That is an old ring type telephone. That is.
That's
rumpus. Sounded like a
George,
landline
what
phone.
the hell are you saying, George? Come on.
Yeah, like it was one of those fax machine phone scan, like from 1987. What do you guys think about that whole, his whole micro inches bullshit? Like who does that?
Well, there are tools that do that, right? For leveling beds and machinery, axles and stuff like that, like precision stuff.
Tell him what that's called, Bev. I was just going to bring that up. Tell him what that and how much it can measure just for the hell of it.
Oh, it's just the law of connected vessels, isn't it? So it's a water level with a micrometer on it.
And how much can the micrometer measure up to, Ben?
I don't know, a 50 millionth of an inch, I think. Is the one
You hear that,
we've got.
Travis?
Uh-huh.
So George reckons that a water level is not sufficient enough.
No, he reckons that measures level, which is a curvature. So that tool would measure a curvature according to George.
Yeah.
To that amount, that sort of. I mean, that'd be pretty ideal, right? You should be able to measure a straight line, and then the deviance from it with a tool that could do that. I mean, if that's what the tool did.
Yep, like on a skating ring, for example.
Yeah. Or you could measure it straight. I mean, one or the other. I mean, either one or the other. You can't have somewhere in the middle and you don't know which it is that you're talking about. That'd be ridiculous.
The problem here, that the great disconnect that you're talking about is the fact that you cannot use a water level to measure curve.
It's like you're smoking a hookah or something.
Somebody's got hot micing here.
Yeah, it's Howard.
I think it's left lane.
It's Howard on his water pipe, I think.
Yeah, sounds like it. Or else he's drowning in the bathtub.
He's been hot micing since cold micing wasn't cool.
It's really weird. It sounds like he's underwater or something. It just sounds like he's got a hooker.
It sounds like Howard's in a fish tank.
Howard! Left lane, are you there?
Travis, mute him for a while.
Yeah, why don't you mute him, Travis?
They're probably sleeping with the air conditioner fan on. That's probably what it is. Yeah, that sounds like an air conditioner.
Why doesn't Ahmad just mute him? He's not here. He's not participating.
Well, we can all agree on that.
Yeah.
Travis
might step away for a bit.
Well, let's just all turn Howard's audio down. Then it's not disturbing.
Yeah, somebody will have to remind me next time, otherwise I'll just not be able to hear him. That'd be terrible.
I think you need to team up with Jeremy, because his idea is that you draw a straight line on a wall, and then with precision tools. Well, Jeremy's thinking you need to draw a line that's long enough, but obviously with your tools that are precise enough, you don't need a line that's too long. So draw a straight line on the wall, and then you measure how far off the ground it is.
And what's this for?
To work out if a straight line deviates from ground level.
You mean to see whether the level is straight or curved? Because nobody seems to know at the minute. I mean, really weird.
Well, yes, we do. I mean, that's the test that I just
we
pointed
say,
out to you.
Those of us that use it say it's a horizontal plane, right? Level is a straight line on a horizontal plane.
But Bev, that was the test that we went over earlier when I talked about in that image with the auto level putting up those 3 targets along a straight line and then measuring the distance down to the surface of the water. That is the test.
Rumpus's test.
Yes, Rumpus's test. Rumpus is just duplicating what I did 3 years ago on a frozen lake.
Yeah, by using an auto level beyond its limits, 2, 4, and 6 miles. Of course, you're going to be
not beyond its limits for setting the horizontal.
Yeah, of course it is.
No, it isn't.
Yeah, it is.
Oh, Jesus Christ. Okay. I'm not going to... Bev, we've been down this road at least 5-6 times. I'm not going to go down the road again with you. You can talk to Parmesan or somebody else, but I'm done here.
All right. See you later.
Wait, George, can you tell me about... So what did you do like a few years ago? You said some experiment over frozen lake. Can I find it somewhere?
Yeah, just go to it's well documented in Walter Bislin's site. Look for the Rainy Lake test. RAINY.
Oh, okay.
Lake.
Yep.
That's the test I did. That's all my photographs and my data and stuff. And Walter Bislin put it all together in a very nice web page there. I mean, it's very detailed. He did an excellent job documenting.
Did he do a drop or the hump for you? Which when he modelled it, Did he do the drop or the hump?
Go read the page.
What was the test for before we go read it again? What was the test set up to show, George? Your observation over a long
I'll read
distance
it for
of
you, George.
ice water.
So
What
I'll
did
read
you
it- I'll read it
originally
for
do
you.
the test for?
I'll read it. It says right at the beginning. The Rainy Lake experiment was designed to show how we can figure out the shape of the Earth, flat or a globe, by observing and measuring a clever arrangement of targets over a distance of 10 kilometers, taking terrestrial refraction into account and using modern equipment. That's what it's designed to show.
That wasn't my question. My question was, what was the test originally for?
Exactly this. That's what it's for.
No, exactly. You're not telling the truth.
No. Okay, I'll answer that.
Go on, George.
I originally set the test up. I was interested in measuring refractive effects over the ice and how much refraction we get. And when I had described, it was in Steve McRae's Hangout once, over at his Great Debate Community. I was describing what I'm doing, and some people said, "Oh, well, can you measure the curve of the Earth, whether the Earth curves or not, using this sort of test?" I thought about it. I said, yeah, I could. And then Jaron from GoBusters also got a hold of me and wanted me to try something. And so I said, well, okay, I'll go ahead and I will modify my tests and set up the targets so that I can determine the drop distances from a straight line down to the surface of the water. So it took off from there. And then what Walter documented is the portion of the test that I was doing on refraction that I modified to determine the shape of the surface of the Earth. So originally it started out as a refractive test, and then it morphed and evolved into this Earth curvature test.
Okay, cool. On your best day, at your best time that you're assuming, what was the amount of refraction that you got?
Oh, I'd have to go back and look. I hang on. I've got a. I did a histogram. If I recall, the most of the refraction all centered around what we call standard refraction, which gives about 11 arc seconds at 3 miles, and the worst ones.
Can you give us real quick before we get into the numbers? Can you give us the way standard refraction is calculated?
I don't want to go into that. Everybody's going to say I'm monologuing. It basically boils all to is what you do is you say you can account for standard refraction by making the Earth slightly larger by going, rather than its radius r, increase it by 7/6, or what you hear about is 7/6 Rs, and it works out to about giving you 11 arc second, raising things in a distance about 11 arc seconds out at 3 miles.
So you use standard refraction in your calculations?
No, I did not. What I said after making 120 some observations, 120 some days, I got a set of data that shows me the amount of refraction that I was picking up. And if you look at the data, it all centers, it collects, it bunches up. You get kind of a Gaussian distribution, a random distribution, but most of the data points all collect around the standard refraction value. So it confirms that standard refraction is a good number to use if you don't know what the refraction is. And you're not near sunrise or sunset where there's great temperature differentials, but it's a pretty good starting number to go with if you don't know what the actual refraction is.
I mean,
George, I know you're, last year I asked.
You're cutting in and out a lot.
Yeah, that's pretty bad, that.
All I got is something about Travis asked, and that's the only words I got.
Well, I want to clarify. So you didn't use standard refraction in your calculations?
No.
No, he just He just standardized the refraction that he thought he got. George, can you hear me better now?
Yeah, I got you.
Okay. So I'm sorry, Rakia, just real quick. I know that it's been a while, and I know that you've had some issues with your personal life, but quite a while ago, I asked you for the data where you're able to make these claims about refraction, like you just did about morning and evening. You know, I would love to see the data that you have to show that what you said happens in the morning and the evening with refraction is actually true. So do you have any measurements besides the observations you made, how you also were able to establish what kind of refraction the morning produces and what kind of refraction the evening produces? Because I think it's a load of horse shit across the board. So,
well, unfortunately, I'm still digging through the rubble, and I haven't found my notebooks that contains that information. I don't know if they survived the fire or not at this point. Hopefully, I'll eventually come across either ashes or remnants of the notebooks that I can pull the data out of. But I did a while back for Larry Scott, as he was interested in the range of refractions that I was getting, and I did take the data from those notebooks and I just roughly put them in a graph, and fortunately that is on the computer here somewhere, and I will find it for you.
So let me just ask you real quick then. So when you're out doing your shots and you're taking your data measurements for the profile, what are some of the data points that you collect? You know, temperature, pressure, right?
One, I'm measuring drop distances from the.
No. I don't want to know about that yet.
I'm okay. As far as atmospheric parameters go, it's temperature, pressure, and humidity.
Okay, those three things. I'm not trying to catch you out. I'm trying to understand your methodology. Okay, so I got 3 points. Yeah.
Well, that's all you need.
Okay, great. So how does that then get translated into refraction?
Well, one is you can use what's called the Critter equation, which is very, very good. I've confirmed it several times. If you wanted to use that to calculate what atmospheric refraction would be. The other way is what I have are actual photographs looking through the auto level, or not the auto level, but a theodolite, where I actually measured the amount of deviation, angular deviation that refraction was giving me at 3 miles, 6 miles, and several points vertical and several points horizontal.
Okay, so what I hear you saying is, in the first one, I couldn't hear it. You said critter?
Kidder, I'm sorry, Kidder. CIDDOR. Go to I think it's a NASA engineering tool book, or NGA, or NOAA. Maybe it might be NOAA. It's called the Engineer's Toolbox, and look at refraction. They have two sets of equations in there. It's called the Kidder equation and Eden equation. The Eden is a simplified version. The Kidder equation is very complicated, and they also have a calculator on there that uses that equation, so you don't have to go through all the calculations.
So again, just for an elementary explanation, they take those 3 points, temperature, pressure, humidity, and then turn it into an equation.
Calculate the index of refraction, And it's a very good equation. And if you go to the very bottom of that page, they talk about a shop floor equation. And that equation, for our purposes, is every bit as good as a more exacting Kidder equation. I've done extensive calculations, verifications between the two, and I found that for the type of work we're doing, if we're trying to get, say, within an arc second, the shop floor equation is sufficient for predicting refractance due to changes in refractive index. It's dead nuts on. It agrees to a high degree of accuracy and resolution as the Kidder equation. Well beyond what our measurement capabilities are using theodolites. Okay, I'm just doing a screen grab. This is the data, but unless I grab the notebook, I won't be able to tell you exactly what time of day these data points are, but I can assure you that on the data points that show a high degree of angular refraction, that those are at or just after sunset. Now let's see. I have this plotted out somewhere. Oh yeah, here it goes. Histogram. Okay, I'll give you that too. But right now, this is all I have because this was taken from the notebooks, but I don't have the notebooks that give me the complete data as far as what the humidity is, the barometric pressure, or the temperature, or the time of day. These are just, I was just looking at all the values plotted out.
Just plug a few numbers in
right now.
Just plug a few numbers in and poof, that's reality.
No, these are actual measurements using a theodolite. These aren't calculated. These are actually measured.
Well, just so I further understand that, your 2 mile marker, let's say, you make a mark and you say, okay, I'm going to adjust up or down, whatever, because of standard refraction or whatever calculation you use. And that's your horizontal.
No, I did not use calculations. I'm telling you, this is raw data. This is what was measured. This isn't calculations.
Did you understand what I was asking, though? I mean, if your horizontal line is hitting at point A, and you're saying it's not accurate because there's refraction, obviously, and this is how much refraction I'm going to adjust for, so I'm going to move that line up or down accordingly. How much did you move it up or down accordingly at the 2 mile marker?
I did not move the horizontal line up or down. The horizontal line is fixed, and then you measure with the theodolite how much the targets move up or down with respect to that horizontal line.
I thought your horizontal line was the water. You measured down to the height.
No. It's established by an autolevel or a theodolite. You set the autolevel up. Obviously, when I'm doing this, I'm not using an autolevel because I'm measuring angles. You can't measure vertical angles with an autolevel. So with the theodolite, what do you do?
But you said in your original test you drilled holes in ice and got the water level. Did you not? Maybe I dreamed.
You're doing the refraction.
I'm talking about creating.
You're asking two different things now. You're all confused.
No, I don't think I'm confused at all. I'm creating a horizontal line. I'm asking you about your 2 mile horizontal line.
Travis was asking about refraction.
This isn't Travis.
Huh?
This is Rakia. I'm asking
about. Yes, I know.
You can't decipher between the two. We were
talking about refraction. What do you want to talk about now? You're not talking about refraction, or are you?
Okay, let me repeat it for the 4th time. At your 2 mile marker, when you shot your horizontal and then adjusted, did you adjust it up or down due to refraction?
No. Can I be any clearer? No.
So then why do you?
No.
Why do you need refraction at all? You're going to adjust for it.
God.
So
all right, let me try again.
Let
me try again. Put your listening ears on.
Can I just clarify, Judge? Did you say no?
Yeah, he said no.
Okay.
Twice.
I said no. I do not adjust the horizontal. What I do
Actually, he
is I
said,
measure how the
no.
targets shift
That's
with
what I thought.
respect to the horizontal.
Don't grow up, Bev. Fuck off.
So you marked the horizontal line at 2 miles, then you measured down to the water level and got X. And then you
No.
went home and calculated.
No. Are we talking about refraction or are we talking about measuring drop distances? You're all confused.
About how in the
juggling this
hell
all-
you measured drop by calculating refraction after you created a horizontal line.
No. I physically measured the drop from a horizontal line.
Was it before or after you well, you already said you didn't adjust for refraction, so it's before. So you measured that drop and you got X. Let's say it's 6 feet. You got 6 feet down to the water, whatever it may be. It's X. Then where does refraction come in?
Refraction comes in as how the targets shift with respect to the horizontal line. You measure from the center of the targets that have been originally lined up with a horizontal line. Now,
well, that is your horizontal line, the center of the target.
You let me finish. The horizontal line is established. Now, what's important here is at the time when we're adjusting the target's heights, are we subjected to a lot of refraction or not? That's the question when you line up the targets with the horizontal. The horizontal does not change. What changes is how the targets are viewed or appear to be intersecting that horizontal line. Refraction will affect that. So when you set the target heights up, you want to make sure you're in a low refractive condition or where they would be there on an average. So I accumulate data over a long period of time to see my targets that I have set up, if they're shifting much above or below that horizontal line that I view through the theodolite or an auto level. Now, by taking this data and averaging it out to find where horizontal truly should be in that image, or how the images should shift up and down with respect to that horizontal, we set the target heights to be at the middle or the average of the refraction to guarantee that the targets are intersecting that horizontal line as if they would be if there were no refraction or
So
no
you
atmosphere.
did adjust the horizontal target, the middle of the target, where your horizontal.
Yes,
with
the
refraction.
target,
Oh my God.
not the horizontal.
I asked you 3 times.
No.
No, you asked
Yes.
if I set the horizontal, not the
That
target.
is your horizontal. The center of the target is your horizontal, moron. You did adjust for refraction.
Fair enough. Okay, fair enough. Yes, I did adjust those.
What are you trying to hide here?
I'm not trying to hide. Jesus
Well, I
Christ.
asked you very simply.
You're too triggered for me to talk to you.
No. I'm triggered. You said no. Did not adjust for refraction when I set the center of the target with refraction to be the center.
I thought you were talking about the horizontal on the theodolite. That is not adjusted. No.
That's the center of your target, isn't it?
No, the targets move, not the theodolite.
Yes, but you put the center of the target where your horizontal and the theodolite is, right, George?
Yes, but the
and you
theodolite remains
refraction,
fixed.
right, George?
No, the theodolite isn't subjected to refraction.
George, are you stupid or are you trying to deceive?
I'm
There's
not trying to
only two
deceive.
answers
You're
to
not
it.
understanding. Don't you
No,
see
it's you.
the horizontal
That is not
established by?
understanding.
There's no point talking to you. You're
Utter
just
confusion, George. Nobody's got a clue what you're talking about.
Can I ask George see if I can understand? See
Yes
if I
or
understand
no?
him. George? George?
What?
Okay, so you have the theodolite, and then you level the theodolite so that it creates a horizontal plane.
How do you do that?
Stop, Bev. Shut
No,
up.
I would like to know. That is a question that nobody's ever answered.
This most trivial thing to do.
No, it isn't, because Sean was telling us at the beginning it doesn't do that. He was saying to Rakia, It doesn't do that.
All the fucking.
That's what the auto level does. The auto level.
A lead on a
establishes the
string is
horizontal.
your level. Right? It's pretty simple. It gets trivial.
You think put something on a
George.
string is level? What do you mean?
Yes, it's trivial.
Well, it's
George.
not trivial to deal with this. It's the horizontal that we're dealing with.
Well,
Yeah, and
okay,
it's
so just real quick, Bev.
George. I was going to ask George a thing.
Yeah, I know.
Until Bev interrupted
yeah,
me.
I know. I hear you, Bev. Just hold off and let this guy go through his questions. I know.
George? George?
Yes, okay. I'm just trying to draw something so that I can maybe clarify this so at least you can understand and I can go away and then you can explain it to the others. I know you'll be able to understand this, but go ahead and ask your question.
George, okay, so you have a theodolite, and then first thing you do is you level it, so you create a horizontal line from that point.
Okay.
You do that first, and then you place.
It's a little more involved than that, but in principle, yes.
Yes, in principle. I'm not like an expert with this tool, but yeah, that's like the first thing you start with. And then you place out the target, and that target has to be like at a known height, so that it's you place it. Would you place it?
No, it's not at a known height. The height is unknown at this point.
Okay. Okay, so the target, I mean, for calibrating, or not calibrating, but to gather data for the refraction part, you place out a target.
No, I'm sorry. I guess I've confused everyone. I don't know. I'm kind of tired of this.
I actually think you got caught out and you don't know how to get yourself out of trouble.
No, I haven't gotten caught out. You guys aren't
They explain it on
understanding
the
test and the procedures. Most of you have no idea how this equipment works, and it's just, oh God, I don't know.
I think they explain it actually. I'm too lazy to read, to be honest. But they explain it very well on the webpage, though. So I guess nobody here has read it, including myself.
No, of course they haven't read it. None of these guys read that stuff.
I skimmed through it. That's I'm not going to say anything.
Just a minute. I'm going to prepare a load diagram, and I'll just go through one more explanation, and then hopefully people will understand. You guys talk amongst yourself. This will take me maybe 5 minutes or so to finish.
Right.
I'm going to go on mute, or turn my mic off anyway. You guys can talk.
Yeah, it'd be good to know how the theodolite establishes a horizontal. Because I know how the auto level establishes a horizontal, and a theodolite can't operate that same way. So, I mean, it's all good and well just saying, yeah, you just set it up horizontal.
So, just real quick, you don't use a theodolite to lay a foundation for a building, right?
No, it measures
That's
angles.
where you would use. Yeah. Right. Use anything that you're gonna build.
No, it'll plot the points, but it'll plot the points on the azimuthal, like on the horizontal plane. It'll plot the pinpoint for where the curb ends, and where the corner of the house is, and do all of that, right? That's what it does. It establishes those angles and those points, and you can plot stuff like that. But if you're after elevation for how high you want the footings and all of that, well, you get an auto level for doing that job. That does elevation, because that establishes the horizontal plane. They're two totally separate tools. One does horizontal, and the other one measures angles.
But isn't that due to the equipment, the theodolite? You can move the equipment to measure angle. Because if you're looking through like an optics, obviously it will be distorted as you move out from the center. But to know the angle, you'll basically just move the equipment upwards, look upwards. Yeah. Then you have an angle, right?
Yeah, so you can measure
while
an
the
angle
other one,
from the bottom of something to the top of something, from how
yeah,
far
while
it
an
is
auto
from the
level
left to
is
the right.
while an auto level is only built to look at level.
A measuring rod, yeah. It has to look at a measuring rod, and you measure the elevation of the land from the horizontal plane that is established by the auto level.
Yeah. I know that auto level has a mechanism, autocorrect, like a compensator mechanism. I'm not sure about if they have the same mechanism in theodolite.
They can't do, can they? Because you can tilt the theodolite up and down. That's why I
True.
say about the horizontal. So it can't work at establishing the horizontal in the same way at all as an auto level.
No, I
Theodolite.
guess it's more work with setting up the equipment, I guess.
And the calibration behind it as well.
Yes.
And the check. I mean, how would you check it? With an auto level, you do a 2-peg test. Is that what you do with a theodolite? To make sure, because it's a different tool, it does a different job. 2-peg test is just to keep an elevation check. George will be able to tell us. He does all of this sort of stuff with the theodolite. Or at least somebody, one of the surveyors that you have round here should be able to tell you that. You'd think.
So, yeah, preparation for making sightings with the theodolite.
Okay.
Setting up. Oh, sorry.
I'm back. All right. I was listening. Pretty much everything Bev told you about theodolites is wrong. Okay. Let's just discuss the difference between a theodolite and an auto level to begin with, okay, before I give you, talk about my test. Now, an auto level, its main purpose in life is to set horizontals. However, you can very crudely, with an auto level, measure horizontal angles. It has 1-degree graduations on the base, so probably within a couple tenths of a degree, you could measure a horizontal angle with a auto level. And you can sort of get vertical angles even cruder because it has 2 lines on the vertical called stadia, which are calibrated to give you 100 to 1. But let's not go there because that's very difficult to use. But the auto level sets horizontals, and you could very crudely, like I say, measure horizontal angles with an auto level because the base is graduated. Now, a theodolite is a superset of an auto level. A theodolite can do everything an auto level can do and more. Now, you can set horizontals just as accurately, if not better, with the theodolite than you can with an auto level. And the way you do it and you don't have to do a 2-peg test using a theodolite, a modern day theodolite. You can collimate the vertical. There's a procedure because of the internal computer inside the theodolite does this all for you. Is what you do with a theodolite before you start setting a horizontal with a theodolite, you first check to see if it's collimated. And the way you do it is you look at a mark way in the distance.
George, just a minute. Larry was telling us his theodolite from 1950 something. That's not got this computer gizmos inside of it.
No, not in 1950. I'm talking about.
Can you do us so we can get a grip on it? Just give us the mechanical way of the when Larry uses his old theodolite. You know, the T2, the one that they always talk about.
This shit, Beth? Why are you always doing this shit?
Why do you gotta get triggered, George? Why do you gotta like
he's saying use a theodolite from the 50s. Nobody uses a theodolite from the 50s.
George
I'm using a theodolite built
Larry
in the
does.
1980s.
Larry's very proud of it.
Yes, the wild T2 and T3, fine. I don't give a shit. You talk to Larry then about using a wild T2 or T3. I don't use those. Okay?
Okay, so we're just doing computer stuff.
I use a Topcon GTS 3B. GTS, okay?
GTS,
3B as in boy. Go look it up. It's a 1 arcsecond auto level. And the way, and Larry has several of those himself that he uses. He doesn't only use the wild, and he has even more modern one. He has some Trimble's, and he has some Trimble's GPS system. So there's many different kinds of tools you can use. This is a tool that I can afford for the type of work that I do. I'm not going out hiring myself out as a surveyor. I don't need the most modern day equipment. The 1980s equipment is plenty good for me, okay, for what I'm doing, and particularly for these tests. So I'm using the Topcon GTS 3B as in boy, 1 arcsecond. All right.
Do you go out surveying, George, or do you just class it whenever you use these tools? Go
to your own channel. Go to your own channel. I'm tired with you, Bev.
I was just wondering about the qualifications of people calling themselves surveyors now, George.
I could have explained this 15 minutes ago, but yet here you are.
Yeah. As people get on at me for saying that,
are you not interested in listening, George? Bev?
I'm trying to learn.
Then shut the fuck up then.
No, that's just George goes on a ramble. He never actually answers any of the questions you ask him.
Oh, you're asking him to talk about the field lights from the 50s.
He just said yes, because he said computer. Cares? Well, doing computer stuff doesn't solve horizontal.
You ask him how he asked how you calibrate the field lights, which he has, and that's the one he has, and he'll tell you how he calibrated that.
He pressed the button for his gizmos, but he called it an auto level. Again, and then he said he was a surveyor.
I did not call it an auto level. I have auto levels and I have theodolites. Okay?
But when you said that GTS thing, you said it was a GTS
he misspoke,
auto
Bev.
level.
Use a brain, Bev.
All right, I might have misspoke. It's a theodolite. The Topcon GTS 3B is a theodolite. Theodolite, not an auto level, but a theodolite.
And by using that, do you then become a surveyor?
Oh, fucking.
He just said he is not a surveyor.
Okay. Was that another misspeak?
I don't have to be a surveyor to know how the equipment works.
No, but
I'm
you
a
said
professional engineer.
You were
I'm
surveying.
better than a fucking surveyor when it understands instrumentation.
Okay, so you can survey without being a surveyor, right?
Oh, Jesus Christ. Bev, you are such an ass.
I'm just
believe
making sure the rules are okay for both of us, right?
Well, you can maybe criticize his method later, but you need to let him explain it first.
Okay, I'll tell you what, Funk. Let's both put Bev on 0 audio, and then I will just explain it to you, okay? I'm going to put Bev on 0, so I don't care if he speaks over me. All right, here we go. The theodolite. The advantage of a modern theodolite that has built-in computers is it has a digital readout. So you can read the angles just by looking at the display. So you don't have to be using a micrometer and reading numbers off dials and stuff. It makes it very easy. Like on a Wild T2, T3, they don't have these readout displays, digital displays to give you angular measures. You have to look at micrometers, dials on micrometers, and verniers and all that. And it's very difficult, very time consuming to use. Modern surveyors do not use the old Wild T2 and T3s, even though they're much more accurate than modern day equipment. A Wild T3 can measure within 1/10 of an arcsecond. You don't have to do that. For what I'm doing, 1 arcsecond is good enough. And the Topcon GTS 3B is sufficient for that. Now, what you do, the first thing you do is what I was trying to tell you, is that a theodolite can set a horizontal plane or line every bit as good, if not better, than an auto level. Okay? I have now switched over from auto levels to theodolites in doing all my measurement because they do everything an auto level can do and more and better, and it's easier to calibrate. With an auto level, you have to make sure that your compensator is calibrated properly so it sets a true horizontal line or a horizontal plane. And you have to use a 2-peg test, which takes some time. If you get really good at it, you might be able to do a 2-peg test within 20 minutes, a half an hour. With a theodolite, I can do the equivalent thing within 2 minutes or less. And the way you do that with a theodolite is you look at a fine point in the distance. You can set up a target, a range pole, if you want to read a marking off a range pole, or I just use a feature on a flagpole that's a half mile from me. I can see a little bolt on this flagpole, and it takes up no more than an arc second. So I can very precisely set my theodolite crosshairs on this bolt that's a half mile away. And what you do is you first set it up for doing a foresight, and you set your crosshairs. It doesn't matter if it's on the horizontal or not. And so you set your horizontal line on your theodolite to some feature in the distance. Then you go through what's called a collimation procedure. You hit a button on it that tells the computer that you're sighting in the you're doing a foresight to this object. Then what you do is you flip your scope 180 degrees and rotate the base 180 degrees. So you imagine on the theodolite, you can rotate your scope around 360 degrees. With an auto level, you can't do that. So with the so you flip your scope 180 degrees on the theodolite, rotate the base 180, so you're still saying that same point. And you adjust your optics so that the horizontal line is sighting that object. Your horizontal crosshair is sighting that same object, and then you tell the computer you're now sighting that. The computer goes through, corrects itself, and then the readings that you get now are accurate. That if you set your scope on the theodolite to 90 degrees from the zenith, you are guaranteed that you are sighting the same horizontal line that you would see with a theodolite. Or I mean with an auto level. That the theodolite horizontal line at that point now would agree with an auto level if you mounted it at the same spot as a theodolite. They'd both be sighting the same horizontal line. Okay, got that? So in that sense, the theodolite is far superior to an auto level because you can do an equivalent 2-peg test to calibrate the optics and the horizontal crosshairs to sight a true horizontal with a theodolite, whereas with the auto level, it takes a 2-peg test to do that.
Okay, George. Okay, so now that you've gone through that, do you? I'm trying to figure out what are you actually now addressing. I mean, I know that you just explained that, but
well, I was just talking about there was a question as to what the difference between a theodolite and auto level is, and Bev was claiming that the theodolite cannot be used to set a horizontal line.
No,
I'm telling you that it can.
Okay, I thought you were addressing Rakia's question about your adjusting for refraction, making a horizontal.
We sent Rakia down the road.
You can blame Bev for that. He was interrupting and
you sent Rakia down the
the
road.
point.
He's such a fucking.
It was Bev who obfuscated the point. You can thank him for that.
Yeah, mate. It'll all be me.
No, it's not. Yeah, again, yeah. He wasn't obfuscating.
Yes, he was. He was the one who brought up the whole thing about how do you calibrate the level.
I was on about the differences between the two. I was telling you guys.
Okay.
Yeah.
George
So,
then went on to obfuscate
so
it.
the idea is here.
Hold on, George.
That
Maybe you should
Yeah,
turn up Bev now. Hold on.
George, that's why you don't mute people, okay? Take Bev off mute.
And you too, Parmesan.
Me?
No,
Oh, sorry, whoever the other guy was that muted Bev.
Huh?
Punk.
I haven't muted anybody.
Okay.
Okay,
well,
my apologies.
Yeah. George Yeah.
I think everyone needs to understand.
Bev's
There's a lot
audio
of
is turned
questions.
up. I just had Bev turned down because he was interrupting when I was trying to explain the collimation of the theodolite.
Again,
There's a lot
George,
like you just interrupted me when I was talking. That's the
yeah,
thing.
but again, George, that's why we don't do that because of pain in the
Well,
ass.
I don't want to stay here all day trying to explain this stuff, and Bev just makes it drag on and on and on because he brings up irrelevant points.
Well, the questions
you do that yourself.
The questions that people have, if you're willing to answer them, then that's fine. But if you're not, then just say. But that's what most people are here to ask questions. Whether it's you they're directed at or not is another thing.
That's fair.
So,
that's fair.
I'm answering the questions. I'm trying to answer the questions without going through all these interruptions. That's all. I just want to make it efficient as possible.
Yeah. And the reason why I said it was trivial is because this equipment are used every day by a lot of people, and they do this every day. They calibrate this equipment all the time. I think it's kind of like we can learn about it, but I think it's trivial whether you can set it to actually show horizontal.
Is the horizontal a straight line then?
Well, they don't seem to take my word for it.
Established.
Yeah, but they don't
the
seem to take
horizontal
my
a straight line, George.
Yeah, I'm sorry. I'm sorry, but they don't seem to take my word for it that you can use a theodolite to do the job that an auto level does. You can set a horizontal with a theodolite. That's why I went through all that.
No one here disputes whether or not you can establish a horizontal.
Bev did.
No, George. I said the auto level particularly establishes a horizontal plane for use for reference for elevation.
And you said
the theodolite measures angles on the vertical plane and the horizontal plane. It does not establish a horizontal for elevation, does it?
That's what I just went through. Yes, it does.
Yeah, you said it was even better, didn't you?
Yes.
Well, that's wrong,
in terms of accuracy,
George.
yes. Yes, you can set it to a higher degree of accuracy in a good theodolite than you can with an auto level.
Can I ask Bev a question? I mean, the auto level, it points at the thing it makes a crosshair in the diopter, which is aiming at level. So whatever you have in that
horizontal. Yeah, if you want to call that level, good for you. Yes.
Horizontal. Yeah. So if you if you have that theodolite and point it at 0 degree, that's the same place, right? The same thing.
Wait, so you want a theodolite to be able to go next to the auto level, so the auto level can give the theodolite a benchmark of what the horizontal should be. So without you having the auto level there, how does it establish that horizontal?
Why do you straw man every time somebody says something? Like, he literally just said, his point is that you can get the theodolite to do exactly the same thing as an auto level by pointing it to 0 degrees.
But you need to establish the horizontal first to know it's horizontal.
You don't need to do what physical things do you need to do to establish a horizontal? What do you physically need to do to establish?
You get a tool called a level.
What do you? Hold on.
And then what do you do with the theodolite?
What do you think? What do you think? How do you establish it? How do you, after what you've just been told by George? How would you do it?
The point is, if the auto level just points it straight away, whereas here you set it to 0 degrees and then it's pointing in the same plane. That's it.
How do you establish the 0 degrees?
You don't do anything else.
How do you establish
you
0?
set it to 0
I told you, you collimate the vertical angles. I just went through the procedure. And actually, Parmesan, you set to 90 degrees.
That calibrates it on the plane, does it, George?
Jesus, Bev, hold on.
Oh, because it goes against...
A theodolite measures vertical angles from the zenith, so horizontal is at 90 degrees from a theodolite.
Okay. So my mistake. So yeah, you set it to 90 degrees, and there you go. It has the same function as an auto level.
Yeah, that's Why not? Like it's not that. I mean, calibration could be complex. I don't disagree there. But if it's calibrated, then you just point it, and then it will point at the same look, like make the same plane, same horizontal.
Yeah, you guys have obviously used these tools. You know what you're talking about, right?
But you're not explaining me
Or
why not.
are you just imagining?
I'm reading about it
All I was
as well.
trying to do, I was trying to summarize and telling you that an auto level is a great tool. A theodolite is a better tool. The theodolite has a superset. It does everything an auto level will do, but more. A modern day theodolite total station can measure distances because it has a laser ranging
Total
unit
station,
in it. It
George.
can measure vertical angles, horizontal angles to a high degree of precision. On mine, it can do it within 1 arc second.
George, you're just bringing another tool into the fray there, aren't you? We're talking about the difference between an auto level and a theodolite, not the tool that is encompassing both of them together with GPS. Right? Try and keep them separate here.
And also, George, you did mention one a minute ago about that the older one was more accurate than the newer ones with all the information in them.
Yeah, so?
So what? A wild T3.
Well, when were they using the
a wild T3 can measure angles to within about 1 or 2 tenths of an arc second. The modern GPS that I use, and also like the ones that you buy today off the shelf, are typically around 1 arc second devices. An auto level, you'd be lucky to get 1 arc second. These are better than an auto level. You can get some really
there's
good
no
auto
angle,
levels. If you want to
George.
spend thousands of dollars, you can get an auto level that might be able to set your horizontal angle to within maybe about 7/10 of a degree, or 7/10 of an arc second, which is very close to what the theodolite can do. All I'm trying to tell you is a theodolite is easier to use. You don't have to go through a 2-peg test to set your horizontal or verify the calibration of setting a horizontal. You can collimate the lens.
That's
the vertical angle readouts to takes no more than a couple minutes.
Can I just point out here that a 2-peg test isn't to establish the horizontal. It's to check the machine is still operating correctly.
Yeah. And what does the machine do? It sets a horizontal.
That's it. Yeah, that's all it does, George. A horizontal plane.
Effectively calibrating the auto level so it sets a horizontal.
No, you're not.
Accurately.
No,
That's
you're not.
what you're
just checking it's still calibrated correctly.
See, look at this. We've been on here a half an hour and we haven't moved out of the ditch. Jesus fucking Christ, Bev. You ought to be ashamed of yourself. All you do is come to disrupt.
Hold on, George. Are you disputing the fact that the 2-peg test just ensures that the auto level is functioning properly? Are you disputing that?
No. My God.
No!
Okay. Just got clarity. Okay.
I mean, this is what's happening. George says, this is what it does. And Bev says, no. And then he repeats, he says the same thing in different words. It does this. And it's going around in circles. You're both saying... Never mind.
Yeah. I'm going to take a break for a while. You guys talk amongst yourself. I've had enough of that.
Bye, George.
See you,
have a coffee or something, George.
Yeah, go take a nap. Like, go take a shit. Like, go calm down. Everyone gets to talk here, dude. Everyone.
I have read through the post on Alter Bislin's site for that Rainy Lake experiment. That actually looks quite good. And very detailed in terms of what was done, how it was done. Everything was taken into account.
Yeah, the only problem is George doesn't have any evidence as to how he got his measurements for what refraction was happening during his observations. He made certain claims in his videos.
Right.
He made certain claims in his videos about this kind of refraction and that kind of refraction, and he had no data. He supplied no data for it. So
What data were you expecting?
how he determined what level of refraction was there when he made a claim about what level of refraction. Or there's high level refraction here. I'm sorry, where's your data for that?
That was in the formulas in there. Wait,
Not from George's data. So if Walter Bislin plugged in some data, he didn't get it from George, because I asked George for that data and he hasn't given it to me yet because he can't find it.
So yeah, it says refraction coefficient. It talks about the formulas that we need to use, and he does have the numbers to plug in here.
Okay, who has?
On the site, I don't know if who wrote. I assume it's Walter Bislin.
Right.
Okay.
Right.
Fair enough.
Great. Where did he get those numbers from? Are they just generic numbers that you just put in?
Well, air pressure. Okay.
He's only just read it on the site, like 5 minutes ago.
I think that's better than anybody else.
Yeah, but he knows the most. Yeah.
None of you open it, I guess. Instead of asking him, you can spend time reading if you're really...
Well, Travis is already telling him. Travis is telling him that the information isn't there. It hasn't come from George because George wasn't able to supply it. But your man here is going to have read Walter Bislin's thing and be able to tell Travis that Travis is wrong. I'm sure.
I'm answering a question. I'm not like you, Bev. He asked me, I'm answering. I saw the figures in there. I saw the formulas. I saw the data being plugged into the formulas. I'm looking now where the data is coming from, which is what the question was.
Nice.
Download original data.
So did George measure the drop, the hump, or the slope? And did he do reciprocal?
It would be good if you at least open the site to see exactly what he measured. Or what he did.
I've had a few bad experiences clicking the links.
I'm sure you have.
You can tell us.
Oh boy. I found some raw data.
I mean, in all honesty, let's just take it at face value, right? Let's just take it at face value. If I did an observation over the Chesapeake Bay and Walter Bislin took all of my data and crunched the numbers, but I left out certain data points that I didn't have information from, I would tell Walter, you can't...
You're roboting. Can't hear you. You're lagging.
Can't.
This is what you tell
this
Walter.
Information because that we don't have sufficient information here.
What information are you liking?
You just leave a formula loose as well with your refraction calculation formula. Just, put a variable in there and you can adjust it. Numbers.
What do you mean?
You'll be fine.
Put a formula loose. What are you talking about, Bev?
Refraction.
What about it?
Well, if you leave it within a variable, preferably at around 17 feet for 12 or 2 miles.
What does leaving a formula within a variable mean?
It means leaving the adjustment like George does. Like you can have the crosshairs within a 14 to 17 foot variation. Right? If you leave that in the numbers for your formulas.
I'm still confused what you mean. So let's say we have a formula, right? Mm-hmm. X equals or Y equals X squared, right? How do you leave the formula inside
it's derived from real life numbers, right? This formula.
No, it's not derived from real life numbers.
Is it not? You're not getting any real life numbers. So you're just going to make a formula and then use that formula to give you something in reality, or do you take measurements and use all of those numbers to make the formula to then compare?
So here's the level we need to get to. The basics of how maths works. You have a formula derived from whatever method you use to derive the formula, then when you have the numbers, you plug them into the formula. Numbers don't derive your formula. You plug them in and you get the result.
Okay, so well, what have we got as the variables within this thing then? We've got a distance, right? Is that a horizontal distance?
The refraction.
And a vertical distance that changes.
The formula for refraction, you mean?
Well, yeah, I'm saying, like, what have you plugged in for your formula for this thing that I'm saying there is a variable for?
There's multiple variables. Let me just get.
Well, there you go. That's the
you.
way you get it, so your maths can work to the model.
No,
by putting multiple variables.
That's how the those are the variables in the formula, and then you just plug in the actual numbers from your measurements into it. Well, what's confusing about that, Bev?
Well, because you've got a certain amount. George has got like 17 feet, I think I've heard. His variable within the optics. And
when you say variable, what do you mean?
Like the crosshair wavers and the image changes within the crosshair of around 17 feet. I mean, now that's only what I've heard George say. So I don't want to go anything above that because, again, George is the only person that I've heard made this claim. I've never heard anybody else say it, ever.
When I said variable, and whenever you're talking to somebody about maths and you say variable, it doesn't mean something is varying, changing like that, like what you're describing. It means usually represented by a letter, something that you can plug in a different number for it to get a different result out from the function.
We're talking about real life here, though, aren't we? That's what
we
we're
are,
doing.
and this is real life maths.
Yeah, right. So those numbers come from reality first.
Let me just make sure that you understand this, okay? Y equals x squared. X is the variable. It doesn't mean your theodolite changes or whatever. You measure something, you plug that into the formula, your exact thing into the formula, and you get the result.
Okay, so what you're arguing against, you're
That's
saying
what
they're not there or they are there.
Okay, yeah, I'm not sure.
I'm not sure Bev's question.
No, I'm not so sure what you're talking about, Parmesan.
Yeah, Parmesan. So if I'm following this to a certain degree, we're talking about an observation that George made on Rainy Lake. Okay, so the variable does change. He makes one observation. If you want to put that observation as X, so that you have his channel marker, he's got a channel marker, and that is at a certain position in his observation. And if you put that to X as a value, and then you go out the next day and that channel marker is in a completely different position, then it has varied. So then it can't be X anymore. It has to be labeled something different.
No, that's something completely different. Yeah, but here, let me try and get back to this formula. Okay, so for calculating refraction, to calculate the refraction coefficient, the things you need to know are air pressure at the observer height, temperature at the observer height, and temperature gradient at the observer height. So, which is basically you need the change in temperature divided by the change in height. Between the ground level and the observer height. Those are the variables, if you want to call them, that need to be plugged in to work out the refraction.
How high is the column of the gradient? Where do you start?
This is done for this formula to work. You need the air pressure at the observer height,
right?
Temperature at the observer height.
Okay, hold on. So now let's just put the observer height at say 12 feet. Okay.
Yep.
Okay, good. 12 feet. Go. Good.
So you measure your air pressure at that height. You measure your temperature at that height, and then you measure temperature at ground level.
Ground level, where your feet are.
Correct.
So isn't that where you said the pressure and the temperature? So all it counts on
pressure at observer height.
Yeah, that's your eye.
Yeah.
And then at where your feet are. Yeah, just those two.
So
Oh my god. It's...
Also, can you
can we be
ask
confused
two-
about measuring pressure
Yeah,
at speed and at eye
I don't
level?
understand this.
Yeah,
So
no,
simple.
I'm just trying to get you.
I mean,
You're
you have
saying
like
something for
hearing
refraction
impairment,
calculation, but it only seems to be valid where you are.
But you need to. We need to
That's how
repeat
it
here.
works.
Like,
But you're looking out into the distance. Surely that refraction is happening not where you are.
And how many surveyors do you know, or people that use these tools? How many people do you know take all of that into consideration whenever measuring anything?
None.
Come on.
Oh, Bev doesn't know
Let's see
any.
your answer then.
I know
No,
George, for example. I know.
Apart from George.
Okay, I
Ran.
know. What's that guy? Main surveyor did that.
He ran
Does that?
too.
What does he do? He takes in everything. Yeah, he takes
Yeah,
everything
if
into
needed.
consideration. So that's two people. Okay, any more?
But they
what was the
ran.
other
In
guy?
reality, in your someone you might know or
Why does
something
it have
like
to be
that,
in
you know,
reality?
rather than someone on the
I
internet.
don't have to know people specifically. And
You
that's
can't
just the
pick
same.
people who run.
All you're
That's
doing
just
is
the
listening to
same
people on
as
YouTube. Is
saying
that right?
you have to do every experiment yourself, otherwise it's not true. That's not how it works.
That's not what he's saying. He's asking you.
It's the same as what he was saying.
No, we say that surveyors don't do any of this stuff. They stay within the working range of the tools.
Exactly.
Right, exactly.
So what's wrong with that?
So why
Nothing's
would you
wrong
want to
with
look
that.
over miles and miles with an instrument that you would never ever, in surveying, do?
What? What are you talking about?
Well, you tell me someone that uses what you've just told me that they use, apart from George and
This
the main
was
surveyor.
George that
Go
has
on.
done the experiment, so we're
No,
talking about
don't
this
worry
one.
about them two. I'm not worried about them two. I'm
What-
about
who are you worried about
apart
then?
from them two.
What about them?
I'm worried about
Who?
anyone apart from them two.
Who?
Like you and your
Me.
what you're trying to
He's
your
only just
question,
read the
yeah?
website
Yeah?
10 minutes ago. He doesn't know too
Oh, I
much.
see. She's just starting out in this, is he? Oh,
Yeah.
I see. Oh,
No.
it sounded to me like
Yeah,
he was
so-
sort of like, giving it the big one. Like, I know what I'm on about here, when obviously he doesn't.
He's read the website.
What's your
So
question?
maybe go away and have a little, write up.
What's your
Difficult.
question?
Listen, it's difficult to repeat the question when I already know the question because it was just stated a couple of minutes ago. So it's difficult for me to actually take some of you people seriously because we just established the point that we were making a moment ago about the tool that's being used, what the tool is created to do, and what you are now describing using the tool for in an observation for which the tool's not created to do.
So let me
Right?
summarize just so I understand you correctly. So you're saying this Rainy Lake experiment that George did, he used a tool that is not designed to do what he did.
Yes.
Right, okay. I would have
Oh,
to...
you just look
I would
at the
have-
limits of the instruments. Look at the instruments and the limitations. Yeah? That's all I'll say to you. That's it.
So your claim is that George used a tool that doesn't, where the limits don't fit what he was actually doing. He used it beyond the limit of where it's supposed to be used, right?
Here's something. So every surveyor that I've ever known in construction industry has only been using it, within 100 meters or so. Yeah. So, or maybe a couple hundred meters, because the
But you
limitation
can
100
get,
meters.
you
Hold on.
can get
There's a
equipment for
limitation.
$100 and $10,000.
They want
It's very different.
listen. It's nothing to do with that, right? We're talking about accuracy. If you're on a building site and you want to establish a datum 0, that every point will be taken from both footings, foundations, and drainage, that's very important. That needs to be exact, and that's what they do. That's what surveyors do.
Yeah, but exact is relative.
Okay, so which specific tool do you
Oh my
mean
God!
in
Listen,
this case?
guys! Now you guys are interrupting him. Chill out. You've got 3 of you responding to him right now. He's not even finished.
Sorry, I thought you were finished. Go ahead.
So all I'm saying is that, like, if you ask the people around you, the distances in which they use these tools for, and there's a reason for that. Yeah, they don't go and look half a mile or 10 miles or 20 miles.
So can I
They
just
look-
clarify?
Well,
Sorry?
Can
Yeah,
I
go
just
on.
clarify, what tools specifically do you mean?
Well, firstly, the auto level.
Okay.
Okay, wait. When you say what tool do you need for what?
No, I said,
Yeah,
what tool do you
I'm
need?
cooking dinner, so
Like
you
in
carry
terms
on,
of
guys,
what
for a minute.
he
Take
said,
over.
he said these tools, and I wanted to know specifically which tools he
He said
means.
for a building site, the surveyors. So all of the tools that the surveyors use around the building site that he uses, right? That's
Okay, and I wanted to know which specifically they are.
well, they will be auto levels, theodolites, and like George was saying, total stations and GPS. Like it'll be all the tools that the surveyors use, because that's where they all use them tools.
All the tools, all the time?
For different purposes. They all have individual jobs.
So could there be a job where not all the tools are needed?
Yes.
Okay, and that's what I was trying to establish. In the sites where he's talking about, whether using all the tools or whether some tools that were not needed.
No, they will use, the surveyors will use all of the tools that they need to use in order to do the job that they're doing, right? If they are laying out an entire site, then they will need to use all of the tools. But if they're just after setting a footings or something, then they'll only need to use the auto level, because they'll be able to take from the datum site, from the site datum, and adjust their levels from that. They'll know exactly where to put it at what elevation. It's practical stuff that gets used every day.
Okay, so the guy went off, but his point was something like the tools that George used, which I'm just reading through this, and it sounds like he used theodolite and an auto level.
So no like fancy equipment on them, no electronics like he was saying earlier. That's why I was trying to get him to say like the old school tools, which is what Spot On's talking about again, the auto level and the angle. So you've got a horizontal plane and the one to do the angles.
Are you saying that the light has to be old to be called an theodolite?
Say the theodolite. What's the theodolite do?
Measures angles, but
okay,
they can have electronics in. They do have electronics in them today. I don't guess you don't.
Yeah, you can put pattern flashing lights on your tripod as well.
I don't see the point in that, but okay.
You don't see the point in putting fancy pattern flashing lights on your tripod.
No, you can just buy a theodolite.
So yeah, looks like he used theodolite and auto level in terms of the main tools he used for that experiment. Okay, and
did he have the curvature switch on or off? Does it say that?
Yeah. You're very funny, Bev. You should start. You should go to your local comedy club, man. But anyway,
you think it's
this guy is saying that
what is funny about that?
Because he thinks yeah, whatever. This guy was saying that
No. Finish your punchline there, funny man.
it was Bev's punchline.
Tell us.
Yeah,
tell us about the button. We want to hear about that.
So you were saying.
Hello, I can answer that. It doesn't matter whether the curvature switch was on or off, because all I'm doing is setting the horizontal in the crosshairs. In Bev, the curvature switch is not used. It doesn't affect the optics. It doesn't affect angle measurement.
Hey, George, don't tell me. Tell Parmesan. He was the one that thought it was a joke.
Bev, all the curvature switch does is make corrections for the laser light in making a distance measurement on a total station, a theodolite that has the laser ranging in it. The curvature switch only affects the distance measurement capability. I never did anything about using the theodolite for making distance measurements. It does not affect curvature switch. Again, does not affect the angle readouts whatsoever.
Right. Can I repeat as well that the auto level does not have a curvature switch? Or at least my one hasn't. At least my one hasn't got a curvature switch on it.
Affect the angle measurements. Your point is irrelevant.
I was thinking of getting one.
Hold on. We were the guy a minute ago laughed at the fact that there's a button on the side of one of these instruments. There's a curvature button on and off. So
again,
is it
not
laughable?
understanding it. The curvature switch does not affect the standard operation of a theodolite. It does not affect the angle measurements. It does not.
Wait. Is
What's the point in having
is there a curvature switch? Is there actually a curvature switch?
Oh,
George?
You guys are so fucking stupid.
George, is there an actual curvature button or switch?
Yes, there is, and there is also a button that makes the Earth flat.
For correcting the laser light in making a sensitive or very accurate distance measurement. It only is used for the distance measurement.
That's fine. What's it called?
It has no effect whatsoever in the theodolite operation. Curvature switch.
Okay.
What it does is what's meant by the curvature switch. It has two switches, actually, refraction and curvature. There's two settings for refraction, summer, winter. And these two functions only affect distance measurements. If you're trying to sight a distance using the internal laser to a target, it is affected by refraction. It's affected by Earth curvature when you're measuring vertical distance.
Why would it be affected by curvature? Seriously. Surely it's a straight line, isn't it?
Say, you got a curvature switch. You can't use
How can a straight line have two measurements?
Oh, fuck. What in
Go on.
Curvature switch on and off. Easy. Just switch it on and off.
The curvature switch, again. The laser.
I thought it adjusted the horizontal.
I'm trying to explain this for him. Spot on level. When you shoot a laser out, it's shooting a horizontal distance to the, or not a horizontal, but it's shooting a straight line distance to a target. Your target could be up off horizontal, could be at horizontal, below horizontal. The theodolite using the laser measures the distance to the target, the straight line distance. Now, it wants to resolve that into a right triangle relative to your horizontal. So to find the drop distance for horizontal to that target, you have to know how much the drop distance is.
Yeah, the horizontal plane.
Due to the Earth curvature, and you also have to know how much the refractive effects are if you want to resolve that straight line distance into a horizontal distance and a vertical distance to that target into two components. Then you have to know how much of the Earth curve that measurement affects. And that's what the curvature switch is for, just to resolve
I told you spot on.
Straight line distance to a target into two components, vertical and horizontal.
It adjusts that horizontal plane. It knocks it down a bit, doesn't it, George?
Oh, fucking A. No, it doesn't affect the angle measurements at all, or the optics. You have no idea how to use this equipment, Bev. You claim to be some sort of fucking surveyor, and you know nothing about theodolites.
So the curvature, it puts it in a downward direction, doesn't it? It knocks your horizontal down for the adjustment.
You need to stop trying to misconstrue.
Earth curve. If it's Earth curve, then it will be dropping away from your position, right?
Look, can I go back to the other point?
That's the way the adjustment has got to happen, on and off.
Right here, mate. Come on, same point, yeah?
So you were saying...
No, you were laughing. Hold on, a minute ago, you were laughing at the fact there was a switch. So
I was laughing at Bev trying to
no, you
pretend
weren't.
that it makes a difference.
At the switch.
I was laughing at Bev.
He was laughing at my understanding of the curvature switch. Obviously, spot on. It's all right.
Again, if I make angle readings, if I look at the angle readouts of a theodolite, I turn the horizontal switch on and off, it does not affect the readout. The readout does not change at all.
Right, but if so hold on. If you went, so say you had a mile distance, and you say there's a drop. What happens if you went every 100 meters, like the actual instrument's designed to do? What would happen when you got to the end then? In the difference between that and the one measurement?
Correction. It is not designed to only go 100 meters. Wrong.
Well, I know. Talk about. Oh, okay. It's not.
Well, don't interject that in. I'm correcting you. The theodolite is not designed to only go 100
because
meters.
it measures angles. Spot On's talking about the auto level part of it because he wants accurate elevation to the horizontal plane, not just angles,
the
George.
curvature switch does not affect that. I keep trying to tell you that.
So if you
affects the laser portion. The curvature in the damn laser is irrelevant.
Hold on, yeah. So if you actually just did it in 100-meter increments with an auto level, you'd be establishing a horizontal plane, right?
No.
From the last point. Who's that?
Yes, you can use it just like you use an auto level. I told you that.
No, I'm saying
the theodolite does more than an auto level. It does everything an auto level does and more accurately.
And then some. You can even put flashing pattern lights on it.
Yes. You can even put a goddamn stove on it to fry eggs if you want. Jesus.
What if you do multiple setups? Do you have to turn the curvature switch on after like the third setup, or what?
Well, fucking A, didn't I just tell you the curvature switch does not affect the theodolite operation, only measuring distances using the laser. Get the shit out of your ears. What is the fuck wrong with you guys? The curvature switch does not affect the theodolite.
No, but you're saying that the distance with the switch on is different than the switch off as a laser measurement distance. Oh, yeah, that's what you're saying. No, I'm not winding them up.
But it's moot to the experiment, so why are you talking about it?
It only does the length of the laser measurement. That's all George is saying.
Yeah, so he didn't use the laser, so then
the distance to the object, like you've got to adjust that for some reason.
So he didn't do that. So why do we? What are you talking about? He didn't use the laser, so stop talking about it.
Every time you use that as a
button level,
you're just going to keep doing it on purpose.
He didn't use the laser.
There is absolutely no difference in the operation of a theodolite that has distance measuring capability and one that does not have distance measuring capability. They exactly do the same thing, and the curvature switch, you can just think of the total station that has a laser ranging capability as far as using it in surveying operations, establishing level lines, doing differential leveling and all that. The curvature switch is just like it's not even there. It doesn't affect those measurements whatsoever.
Okay, George, can I just get an understanding though before you carry on?
The differential leveling, differential leveling will come out the same.
Yeah, your multi-tool.
Whether or not you have the curvature switch on or off, because that curvature switch does not affect the operation of doing any differential leveling.
Okay, we understand that, George, completely. We're all with you.
Don't.
Yes, we do. I just want to clarify, right? The curvature switch only affects the distance measurement for the laser, right?
Right, exactly.
Okay. So how does the curvature affect how far something is away from it? And why would they have that one labeled curvature switch?
It doesn't affect the distance something is away from it. I said it affects when you take that distance. Say you're sighting something at a slope that's off the horizontal. It's beneath the horizontal. You're sighting you're up high on a perch and you're sighting something down closer to the earth. So you have a slope downward.
George, come on.
You shut up.
Up on a perch with your bloody multi-tool.
Stop it, Bab. Stop it. Stop it. Let me finish.
This is fantastic, George.
Let me finish.
Finish.
Let me finish. Now, suppose you're on a perch up above the earth, several hundred feet or whatever. and you're going to sight an object in the distance, say down near the surface of the Earth. So your sight, you've got your scope pointed downward beneath the horizontal. It's sloped downward to that object. The distance that the laser tells you are from that object, it is independent of the curvature switch. Okay, it gives you that distance. Where the curvature comes in is if you now want to resolve those components into a horizontal, that is, how far out horizontally is that, and how much vertical is it from the horizontal, then the curvature comes into effect. You turn the curvature switch on, and it will affect the vertical and the horizontal components that distance is resolved into.
George,
the distance is not affected by the curvature switch. How it resolves that
George, you've
into
just said
two
it affects
components.
the vertical and the horizontal when you switch it
Oh,
on.
fucking A. You are so goddamn dense. It's unbelievable.
You did say that, though, George.
Bev, you...
Come on, George.
The distance to the object when you're watching, when you look at it, it's because it has to correct for it. That's what it is. Okay, is that what you wanted to hear?
No, it doesn't correct for the distance. It corrects for. Oh, Jesus.
The measurement. It corrects the measurement.
Oh no, you're not.
Yeah,
you're not
that's
being
what I meant.
stupid,
It
are you?
corrects
You're
the
not understanding
measurement
what he's on about.
to make sure it's an accurate distance.
Are you sure there is a curvature switch, George? It's not just something we've just made up, is it?
George,
How
are you
does the
saying?
laser get a distance as well? That's the other question.
I mean, haven't you? Spot on. You can just buy a fucking laser measurement tool at your local store. It's not magic.
Oh yeah, what sort of
Yeah.
distance do they go to then, Clever?
Is your
Dogs?
curvature switch
How far does
calibrated?
your laser tape measure go from the local store?
Who calibrated your lasers like curvature?
I know. Let's talk to the other guy. He seems to know what he's on about.
Hold on 1 second, guys. Guys, 1 second. Let me just say welcome to Bevan and his peoples, and everyone. YouTube search Try Thinking for some great content on YouTube, and this is all happening in Brandon's Flat Earth Discord server. Thank you. Please continue.
I'm sorry. I have to make a slight correction here for Parmesan. Is the Earth curvature switch? Different theodolites give you different capability on distance measurement. When you set a distance measurement, you can get components of that distance into a right triangle, and because of the curvature switch, what you can also get off the theodolite is the equivalent arc that would be going over the surface of a curved Earth. You shoot a distance, a straight line distance to the target. That's a chord, kind of like a chord. It's a straight line distance. But if you want to get the actual curve or the arc to that object over the surface of the Earth, then you turn the curvature switch on, and it will compute the length of that arc rather than the straight line distance.
So basically, the straight line measurement to compute the actual arc distance.
Exactly.
How does it get the straight line?
Switch on.
Go on.
I just have a question. When you switch on, when you switch on the curvature switch, does it go like this? Does it make a really neat noise to let you know that it's kicking in?
Boom!
Just wondering.
Wow,
Thank you.
smart.
Helpful. Don't learn some math.
All it does is adjust the readout of the distance.
How do you get the distance? That's my question.
The laser light.
Laser light, right? Okay, so what sort of distance? What do you mean laser light? What, so it goes
You
one
shoot a
way and then
laser.
what?
It's got an
Bounces off
internal laser.
something?
It has an infrared laser.
How does it
inside
receive
and
it?
shoots to
How
a
does it
target.
receive it? How does it receive it then? Yeah?
Yes. It shoots a laser out, and you have to have a corner reflector or a retroreflector in the distance to reflect the laser light back to the theodolite, and it receives the lit. And by timing, it can compute what the distance is by knowing the time it takes for the laser light to go out and return.
All right, thank you.
And who calibrates, George, who calibrates
Here's a
that?
common misconception, too. is you have to have very special reflectors called a corner reflector or a retroreflector in order to measure distances. You can't, for example, take a theodolite and shoot a building and shoot the side of a building and get a distance readout because you can't get enough reflected light off the surface of a building or a pole or something. You have to have a special reflector set up precisely to the distance that you want to measure.
Right, okay. Right, okay. So you know the distance to whatever you're trying to find the distance to, is that what you're saying?
No! You say, oh,
right, okay.
Jesus.
So is that what you're trying to find, yeah? You could put someone there with one of these reflectors
Hold on, no,
and then
spot on.
get a measurement to do that.
You're just derailing
No, I'm
now.
not.
Yes, you are.
I'm derailing.
Yes, because you're going off on irrelevant stuff.
No, we're not talking about what you want to talk about. Is that what you're saying?
No, because you're
yes, it is.
obfuscating what
All right,
the question's been answered, and you're just creating new things, irrelevant things to try and.
So, do you understand more
do,
about it now
if
than
you
you did
want
a
to
minute
measure
ago
the
because of
distance-
my questioning, or you know, like, or did you just not listen?
Spot on level. If you want to measure the
Yes,
distance
ma'am,
to something, spot on. If you want to measure the distance to something, you have to physically go to the location of what you want to measure and put a reflector there. You have to put a target that will reflect the laser light back. You might not know what that distance is, but you put a reflector there to get the laser light to reflect back to the theodolite so it can compute what the distance is.
Yeah, I got it. Yeah. So, are you saying that measurement is different in the summer than it is in the winter?
It can be because of refraction. If you are
the distance from you
not the straight. No,
in the summer than the winter.
Wow,
Jesus
he's
Christ,
banging the
listen.
table there, Spot on. You best watch out.
George, hold on, guys. Hold on a second. George, relax, please.
The straight line distance is not affected. What's affected is the arc distance. If you want the theodolite to compute what the distance is along the arc that follows the Earth.
Yeah, but why would you want to do that?
To get an accurate distance along the surface of the Earth. That's what we deal with.
You've just done it. You did it.
No, you didn't.
Without the switch.
When you shoot a laser, it goes a straight line. It does not follow the curve of the Earth. Oh, God. I'm going to...
George, you got to relax. Don't start shaving on us.
But Jeremy, I think this you had a question a few days ago about how do we know distances, right? Was it to do with like 3 points and then the distances between them don't work?
You talking about spherical access?
Yeah, you said something like, and you were saying that it's hard to know.
This is getting derailed now. He's derailing it.
It's hard to know.
Yeah, let's not derail it.
You don't need spherical access.
Spherical.
It's redundant.
Spherical access.
But this is a way to know the exact distance.
The exact distance, you measure it using first order measurement techniques, don't you? That's actually how it's done in reality. With actual physical measurements.
Oh, so that's
they
how
didn't
it
have
works.
lasers back in the 1920s now, did they? First order measurements, yeah. No, they still work off of those first order measurements.
And there was no curvature switch back then. And I'm not so sure there is now.
Is it calibrated?
Maybe because it's the
to
curvature.
fake the globe.
It's a gimmick. It's a gimmick.
What, you think the curvature switch is real?
What I wonder, Bev, is are you real?
Is there
the reason why they told them-
It's a real deal.
They still had to do the same sort of thing back in the day when they didn't have the laser total stations. They had to go to tables and compute and make corrections for Earth curve using their notepad and their slide rules and stuff. You don't have to do that now with the curvature switch. The internal computer, the theodolite, does that all for you.
I can sum up the last 30 minutes. We have been talking about the feature which George didn't even use, and
that
it
may or may not actually be there.
It doesn't. It doesn't even affect it. So why the fuck
may
does it
or
matter?
may not exist.
Okay, who gives a shit because he doesn't use it?
But George has just been talking about it as though it's real. Like, do you think it might be a good idea to make sure that it is real? Because if it isn't, then what have you been listening to for the past, God knows?
Like,
he didn't even use it, regardless.
Funk is telling you correctly. It's irrelevant. I don't care about the distance measurement. The curvature switch should not be bothering you because I never made any distance measurements. I never used that function. All I use the theodolite is to set up a horizontal. None of this stuff is relevant to my experiment. If you're interested in my test, quit obfuscating with all this irrelevant nonsense.
Hold on, George, but you're not understanding how these. You're not understanding how this proves flat Earth. If we can piece you off by asking irrelevant questions, that means flat Earth.
Who's the baby talking?
It doesn't. You're just making that up, right? That's not what we're doing here. We're just talking with George and the guys, right? No, it's not. We're just talking.
Almost as if you don't give a shit about the experiment which can disprove your idea of the world.
What?
Everyone is in the side channel.
What have we got? Has the order gone out?
George is getting mad. George is getting mad.
Has somebody put the
That's
flip
exactly
the
the reason. It's to get George mad. So you can prove flat Earth by making people
calm
mad.
down.
Is everybody on George White Knights now, are we?
Yeah, L'Oreal, you will survive
this. I'd like to talk about the horizontal George made. How did you make this horizontal, George?
No, don't get George. He's calming down. Cocoa time.
All right, take a nap, George. Go take a nap. Have a coffee and a cake.
I'm reading through this page, Jeremy.
How do you make it horizontal, Jeremy?
Here we go.
He uses
it's George White Knight in the White
Here are the
Knight
tools
squad
he
coming
uses.
here.
He has an water level, a theodolite, an ice angler to dig out holes, a corner reflector, and some pipes for targets. And he has a dog as well. It says Khan, so I assume that's where.
No, it's a good thing we know the dog's name. Absolutely, yeah. That's critical.
Important. So he basically uses, theodolite and an auto level. He puts targets in the frozen lake, I assume. And then he sets them up at a given distance. And then he checks whether they're going to be and specific heights. He sets them up at specific heights. And then he checks whether they line up in a line or whether they don't line up. And then he changes the heights and he checks again. Do they line up or they don't line up? Takes pictures of all of that.
I think we all have the same issue here with how the horizontal was made. I mean, so he's how many miles was this over?
Jeremy, you don't even need a horizontal.
Wow.
How do you measure?
Do you measure horizontal without knowing a horizontal?
He's just checking
all the targets lines up. That's all you need to check.
Oh, we're on about Rumpus's test now.
But
back to Rumpus's test.
I'm usually snap on with the responses, but what do you mean you don't need to make a horizontal?
No, you don't need horizontal. What Bev didn't do is you can make a level.
No, we're talking about how George.
George
made it.
No,
like we're talking about how George made the horizontal.
Well,
George said he made a horizontal.
You know how he made the horizontal.
Yeah, he went 6 miles through a theodolite or something.
He made horizontal with theodolite, right?
Over 6 miles. Is that an accurate way? Would anyone ever use a theodolite with that range? When it
I think
would anyone ever use a
he's about to say that my 400 meter water level didn't establish a horizontal, right? Is that what you were going to say? That our 400 meter water levels didn't establish a horizontal.
Not everything's about you, Bev.
Well, he did say, Bev, this is what Bev didn't do.
Well. I was there as well. I was there with my 400 meters. So, yeah, crack on.
You're retarded too.
Who said that?
It sounded like Gary.
What I'm asking is why didn't Bev bring his auto level and try to make a straight line
Why
between
doesn't
the
anyone
ends,
actually
between the
answer who
ends
it is when you
of
ask
his
who that
level,
was?
of his water level, and see if all three ends can line up together?
Because
That's
that
what I'm
wasn't the
asking.
test.
Now, I
That's quite
know it
simply.
wasn't the test, Bev, because that's the test that will prove you right. That's why
No,
you didn't
that's what
do it.
you want us
You're
to do. You do
talking
it.
about your bullshit. What did you prove? The two water levels can be level to each other, Bev. What did you do?
Shared
What did
Do
you
you know
waste
straight
your
anything
line
time
about?
on?
segment.
Hey, whoa,
Tell
Big
us,
Mel.
what did you waste your time
Hey,
on? Did
hey,
you
hey!
dance
You
this
don't
time too?
understand. You do not understand the test, do you?
I don't understand the test. So please
Right,
explain it to
explain then
me.
what the test.
Please
No, you
explain it
explain
to
what you.
me. Please.
No. Look, there's plenty of information about that. It just seems to
Plenty
me
of
like everyone
information.
talks
None.
about. I was there. There's loads of it, right?
I know
So
you were there. I
if you want to
wasn't.
find
So please
out,
tell me.
we've been talking about doing
Why
a
you
test
tell
for
me I
over a
don't
year now.
understand and then don't explain it to me?
I don't feel the need to explain to you. If you don't understand it and you're talking about it,
How
like you
will
do
I understand it if you
then
don't
you need to go
explain
and
it to me?
understand it.
God, can you quit cutting him off,
Because I
Chuck?
can
Just let him
tell.
talk.
I can
Because
tell
it
that
keeps
you
repeating
can't.
itself.
I can
You
tell.
wasn't there. Yeah, I know.
I can tell you do not understand it by saying that the test is useless. That's why you do not understand it.
Yeah, because
So,
what
there
it
you
is
go.
is useless. Absolutely useless.
I think it is
Yeah,
quite
exactly. You
useless.
don't
What did
understand
we
it.
learn from his test?
Hello? Hello?
It's Spot On's test as well, Chike.
Oh, yeah.
Yeah.
Also, it's his
What
test
did
as
you
well.
learn from this test that we didn't know
Nice.
before? Tell me.
Hey, hello? Can I speak a moment?
Yeah, George.
Yeah, we can hear you, but you're quite quiet.
Yeah, well, I can't.
You gotta calm down, though.
Sorry,
We
I
don't want your
can't
blood
fix it.
pressure.
I don't have an external mic right now.
George, you're good, dude. Just don't be like pulling your guns out.
Okay. You know, Jeremy's interested in how I establish horizontal. Some of you guys want to know it. I was willing to do this 2 hours ago, and you let Bev sit and derail and deviate the conversation. We had to get into, why don't I use a theodolite from the 50s? What's a curvature switch? Is there a curvature switch?
Don't be such a crybaby. Just
Shut
go
up.
on
All
about
this
it.
is irrelevant.
Snowflake, George. Come on.
Come on, you guys are being crybabies about it.
If you want me to discuss the test and tell you how I establish the horizontal,
George,
you have to give Jeremy's going to have to give me 10 minutes uninterrupted and serve on mute everybody so I can speak.
Oh, come
over
on,
that 10
George.
minutes.
10 minutes.
You're not willing to do that.
Ain't no one got time for that.
Absolutely not, George. 10 minutes. It's bad listening to
Okay,
waffle on for
you can argue
45
all
seconds.
you want about my test because I'm not going to sit here and let people interrupt me and have us not get to the bottom of how
I thought it was Rumpus's test.
Hold on, is your test?
So fuck you all.
Is your test a practical test? You know, without optics, or is it optics, or like
I
purely?
mean, you
optics?
can just go on the site and read. It's actually very, very detailed, to be honest. So
No, I've seen it. Oh, I know it's optics. Yeah.
Well,
optics. What are you talking
hold on. You are presuming these people can
Yeah,
read.
you don't understand, do you? By saying that, you obviously don't understand. What do you mean optics? What do you mean by that? I mean, like,
everything you see is optics. When you use your ruler and measure something, that's optics because you're seeing the ruler, right?
Yeah, there's a difference
We're talking
between
about the
making a
Were you
long.
wearing
We're talking
glasses
about
when
the
you
instrument.
There's a
took the
difference.
measurement?
Hold on, there's a difference between making a long-range optical measurement over miles and then looking at a ruler.
Exactly.
I wouldn't consider those being the same optics. Come on, man.
I think most people in here know what that meant, but you're just being.
Optics. Is this
He's
an
just
optical?
being a bit
No, it's
silly,
not
isn't he?
optical.
That's all.
Sophistry.
We all know what. We all know. We all know.
Genetic
Like people
surveying.
talk a load of shit, don't they?
Pure sophistry.
No, you never get a differentiation between measured change in elevation and curvature. You never get an explanation on the difference.
If you do have a problem, it probably means you're like it's not calibrated or something. I find it hilarious that people talk about the test and still don't understand it. It's hilarious.
What I find hilarious is that I want to see this test and I can't. It's not to be found. No.
Oh. Have you seen the geometric proof?
It was a secretive test.
So spot on. You did a test with Bev, right? Where can I find this?
Have you seen the geometric proof?
Which geometric?
Well, you obviously don't know it, then, do you?
Yeah, according to Bev,
I'm asking a question.
Segments, any straight line segments connected together is a straight line. Mm-hmm. Geometric proof.
So what's the geometric?
Yeah, point to point, and they had 8 points.
Point to point.
So was your test an optical one?
I can draw three.
No, they're water levels. They're actually on posts.
Okay, so
in situ.
is it an optical test?
In reality. Well, you look with your eyes
Does
at
it use
a
optics?
distance of about 2 foot.
Ah,
so
it
not
is
even long, not even long distances. They're not using any of the optical tools that I was referring to when I said optics. Yeah.
I saw optical tools.
See how the goalpost shifts as soon as it's the shoes on the other foot. See?
Everyone knew what I meant by optics, apart from you that's trying to make a big thing
no, because
about it. So let's move on.
Sophistry. Again.
There's an absolute difference between... There's a huge difference between looking miles through the atmosphere and looking 2 inches at a ruler or something tangible right in front of your face.
Or the water level with the water in it, establishing its own horizontal.
So how far are you looking through the atmosphere in your test with Bev?
About a foot, about 2 foot, maybe 3 foot.
How far were you looking at? Down?
3 foot.
3 foot, is that how far?
Sometimes just 6 inches.
6 inches. You were using a theodolite to look 6 inches.
No, the theodolite. Where did you bring that in?
He's got him mixed up with the optics again, hasn't he? He's got all mixed up.
Oh, you're talking about optics.
Picture, which I thought was your test. Was that not the case? Maybe I misunderstood.
Oh, it's all right. If you don't understand it, then it's fine. You know,
somebody posted the picture.
I mean,
can you answer my question?
I suggest just doing a little bit of homework. Find that. Go on the website on the level.live.
Why would you?
And it's all on there. Yeah.
Why would you use a theodolite? Why would you use a theodolite to look only 6 inches away?
We don't.
Who said
but
that?
Why did he say that?
Wow. You guys gotta keep up, man. Come on.
Why did he say that? Is that what you're saying?
Yeah. Go on, ask him. Yeah, why did you say that about the theodolite?
Exactly. Why are you looking 6 inches away with the theodolite?
No, we're not. Ask him why he asked us if we were using a theodolite. Ask him.
He
just said you is not.
Why is he looking 6 inches away?
Why did you ask that?
I have a different question. I have a different question.
Yeah, this is good, isn't it? This is why it's so hard to get people to talk about the test.
Spot on the level. I've gone onto your site. Where do I find this specific experiment?
Well, it's not hard, mate. Just search the site. There's loads of stuff in there. You'll learn a lot.
No, I want to know about this specific experiment. I'm looking for this specific.
It's not on there. It's not on there. You had to be in the Discord.
I said the geometric proof.
Can you share where I can get to it? Where I can find it?
The Discord.
It was live, mate. It was live.
Live. We do live
as well. It was advertised. It's a shame you weren't there.
So, do you have like paperwork with it, like records of your data?
No,
Where's your data?
We were too busy doing the test.
Yeah.
To be recording.
Do you have pictures?
It was just our test, dude. All right.
They literally have nothing.
So you have nothing to show for it. You've done the whole.
Yeah,
test.
we have. We've got loads to show for it.
Well, show me something.
You're literally showing nothing.
Go on.
Yeah.
Go replicate.
You're literally showing nothing.
See what you get.
There's nothing to replicate.
Do you know the method? Do you want to know the method?
You say no, we don't have this.
Do you know the method?
We don't have this. I don't. Tell me. Show me where your method's written up. Show me your results, your data, your pictures, anything.
Okay. Well,
everything.
I think I did a presentation over at Jose's, but it'll probably be on the channel. that we did.
I'd like to see
so
the
you'll be able to
actual
see all of the geometric proofs. I think Gary, if Gary's in here, he came over to see the level is horizontal geometric proof.
I saw Bev's
That's not what I'm looking for, Bev.
And he
I'm
couldn't
looking
rebut that,
specifically-
right? So that was the initial, that was the start of it, right? So we've got absolutely everything all the way back from first principles, starting at a straight line. And we've got the proof of it all to show that
Bev has
level
nothing on
is
this
horizontal.
test. That was a secret.
And we can
Then there was
scale
secret
this all up.
Why are you
Everyone
talking
can do
about
it.
Nothing to present now, so he's got nothing to say.
I'm just making me tea and
But, hold on. So you guys did some test.
Parmesan,
Some
they did a test and they literally did nothing with it. They didn't record any of it. They have nothing to show for their claims. It was completely worthless.
No, for me and Bev, it was like exactly what
It
we
was
wanted to do.
completely worthless for you to bring it up here now.
Did you at least go down the pub and have a pint afterwards?
You're all talking about optics all the time. I'm talking about something that you can actually see really close up.
Okay. Go on.
What's wrong with you, Parmesan?
Elaborate,
They have
please.
no documentary evidence of this test at all. Okay, they got
Geometrical
nothing.
proof, straight line.
So where's your test? Right. Okay. Let me
There's tons of
did you
memes about it.
at least have fun?
Did you have fun, Spot?
He's jealous. Do you want to come next time? You think you might have missed out on something?
Are you jealous? Do you want to come next time? No, Beth. We just want you to document your tests.
We did. It was live on
Nah,
Discord.
but you don't have anything to present now, so you didn't document it, did you?
Oh dear, must have mean that it doesn't happen then, right? Just forget about it, Gary. It never happened.
It means you
Well,
have
you
nothing.
wouldn't be
That's-
interested
you
in it
have
anyway.
nothing to present.
It
You
wouldn't
literally
mean
have
anything
nothing
to you
present.
anyway.
All we have is some assertions with nothing to back it up.
Hold on. So because you can't use Bev's information for his test, that automatically means he didn't do it?
That's
Because
not what
you
I said.
can't
He
use
has literally
All I
nothing to
have
present.
go on-
What's his
hold on,
claims?
I'll answer that one. It means
Worthless.
all I have to
How
go
about-
on is Bev's word, which is not good enough for me. I want to see something like a measurement, some readings, some pictures, something other than Bev's word. I did this test, which he is not even telling me what he did or what it showed. So I've got
Parmesan,
nothing to
did
go
you
on.
know? Did you know I can fly when no one's looking? That is what's going off here.
Basically, you see, Bev, if you want to know what it needs to look like, you go and look at this Rainy Lake experiment and how it's documented in so much detail. You can download the raw data. You can you have a map of the locations. Basically, everything you want to know. You have a picture of the equipment, a detailed list of the equipment used. That's what it needs to look like. And I can't see anything from your side, not even close.
Do you happen to have the hypothesis for that Rainy Lake experiment?
I'll post the link for it. It's all here. It's all here.
I love the hypothesis. It's hilarious. It's so funny.
Here you go. There's the link.
Yeah, if anyone wants to read the hypothesis out, if you want to have a little chuckle. Flat Earthers listening now. You need to go spend some time with Bev and get your geometry together, right? I've learned a lot over there. I haven't spent as much time as I'd like, but you should all go check them out. At where are you guys hanging out now? Emma's or the other one?
We're mostly on next level.
Next level. You're on some next level shit, right? You need to go get on their level.
You want to learn about geography, how theodolites and auto levels work? That's the place.
What up, Jeremy?
Definitely
What
not
up?
a place. Definitely
So,
not a place to learn
I
anything.
hear some dead air. What's the biggest, newest hype in crypto? I got $200. I want to drop myself.
I don't know.
I have a question. I have a question for Bev, and I want you to listen, Jeremy. I want you next. Bev, did you compare?
I've just got back.
Okay. Yeah. Did you compare your level your water level to a straight line.
Hey, Jeremy, what's the
shared
hypothesis
straight line
of my,
segment.
No,
what's the,
to a
hypothesis?
straight line.
Yeah,
Hey,
2
Jeremy,
points.
what's
You
the
know what that means,
hypothesis
right?
you're talking
No.
about?
Did you compare your water levels to a straight line?
Yeah. Geometrically, yes.
No,
Hey,
geometrically.
Trike,
Did you compare it to a straight line?
Yes.
Yes. How
Hey,
did you do it?
Trike, just a
Wait,
minute. Hey,
wait.
Jeremy, what's this hypothesis of the Rainy Lake experiment you're talking about? There was no hypothesis.
Oh, I thought somebody made a hypothesis for it. Maybe it was
No.
It was if the
Again,
lake
you talk shit. You
appears
have no
complex.
idea. Again, you talk shit. You have no idea what you're talking about.
Shut
You've
up,
never seen the
George.
test. You've never seen the experiment, and you spout nonsense saying.
So you have no. You have an
think the
experiment with
hypothesis
no.
is hilarious. There is no hypothesis.
You have an experiment. You have an experiment with no hypothesis.
Oh fuck! You're an idiot.
Anyways, go ahead, Bev. Go ahead, Bev.
Wait. I want to continue with Bev. How did you make?
What do you mean you want to continue with Bev? What's this?
Well,
Am I on trial or something? What the fuck are you talking about?
You said you compared.
I said yes, geometrically. There is a geometric proof that goes behind the backing for the water level being a tool for us to help establish a shared straight line segment in reality. Yes.
Listen, Bev. That's in contention. You say water level is straight.
Your understanding of geometry is in contention also.
You need to find another way to create a straight line.
What proofs do you have?
Level.
What proofs do you have? What tests have you done to show that a water level does not establish a horizontal
Do you agree
plane?
with me, Jeremy?
I'm just saying that it's a horizontal plane. Earlier you said that it's line. Like, how do you know that in your test it was collinear? The points have to be collinear.
If it's a horizontal plane, then all the straight lines on that plane will be called horizontal straight lines.
How did you establish a horizontal plane?
By using a water level.
Look, Bev, I don't know if you pretend to be stupid or real stupid, but that's in contention. That's what we argue about.
That's what you lot argue about. Yeah. I just tell you, a water level is a tool for establishing a horizontal plane. It's got 2 points, one at each end of the water level. Neither will be higher nor lower than the other.
That's a line, not a plane.
Wow. That's clever. So you could leave one of them at one point and put the other one wherever, right? Anywhere.
Yep. And imagine a line between those. Sure.
Yeah, and make a plane. Yeah. All the points at equal elevation would mean you establish a horizontal plane, wouldn't it? No answer? Too hard, obviously.
Maybe take 4 points next.
Well, yeah, 4 points. However many points you want, infinite. You can move one end of it to wherever you want, can't you? And it will still establish a horizontal plane.
It's a lot of dead air for a fucking simple question.
Tricky, isn't it? Is it the fact that it's a horizontal or that it's a plane?
Reality. Sorry, Bev.
What's your problem with it? Is it horizontal that's the problem, or is it the plane that's the problem? Two-dimensional surface.
I think it's the definition of horizontal, right? You know that.
Listen, Bev, you can't tell us that level is horizontal. That's what we argue about. You can't tell us.
I can make that as an initial statement.
That's the very definition
in a logical statement, can't I? I can make a statement and then prove that, can't I?
Do you know what's begging the question?
For the record, Bev, doesn't the sphere model also predict that this exact thing will happen?
What, that level is horizontal?
the word horizontal doesn't mean what you think it means in this.
What do you think it means? It's a straight line or plane at right angles to vertical. That's precisely what it is.
That's how horizontal can be used, but when we're talking about horizons and horizontal across the globe, we're not talking about it as a straight line in that aspect, are we? I mean, that's not the,
I don't know.
the way that
I would. A horizontal
used.
would definitely be a straight line, at least.
Right.
Yeah, I agree with.
Oh, wait a minute. Grimm's about to bend it for you. He's about to give you bendizontal, I think.
That's because, Grimm, you're envisioning a curve right off the bat.
Grimm's new school. Grimm's new school. You guys are old school.
Bev, I agree. Horizontal is a straight line. How do you establish a straight line?
How long can that horizontal straight line be?
Infinite. How did you establish
so if you go along
straight line?
If you go along that horizontal line and do a perpendicular to it, you'd be able to call that vertical, right?
No.
Infinitely. Well, vertical and horizontal are perpendicular.
No, I don't.
So how long can you make a horizontal line then?
Infinite.
Right, and all the way along that horizontal line, you could have a perpendicular, and that would be vertical, wouldn't you? Because horizontal and vertical are perpendicular. That's one of the rules.
Negative, Bev.
Oh, so now you don't want to have horizontal and vertical being perpendicular.
That's not what I said.
You said negative.
A line can be infinite. Can be horizontal at one point only. That's what we argue about.
I'll make a definition then. A horizontal line, how long can that be? Because that was the initial question. How long, as in length, can a horizontal line be? Please, line. Remember, 2 points.
The line is infinite.
A line can be infinite. Can be horizontal at one point only. Hard for you
You think a point can be horizontal?
Listen, all you freaking trolls, listen, you have to stop. Listen, we are no longer talking about horizontal lines. We are talking about horizontal points, okay?
Yeah.
You have to understand that. Get that through your thick fucking heads.
No, I don't think you can have a
horizontal. We're talking about horizontal points.
And that's
you
what
can't
Grimm
have a
was saying.
horizontal point. A point has no parts.
Jeremy,
how does the thing with no parts be horizontal?
Bendizontal.
Listen, Jeremy, stop trolling us, okay? We have to start talking about horizontal points, gentlemen.
Horizontal lines and horizontal planes no longer exist. Because if they do,
they don't exist.
If they do, it's fucking flat Earth, right? So we have to do away with them because that's the only way we can now survive is to do away with horizontal
I know
planes and lines. They're gone.
Be checked, Bev.
Bendizontal, that's the only way forward.
So, tell me, Jeremy, if he didn't compare his water level to a straight line, did he prove anything?
Do you understand that you can't have a horizontal point?
No, it was a simple question.
Does Jeremy know what the test is?
I've never even heard it.
Well, there you go. So, why are you asking Jeremy whether he thinks we proved anything?
Advertised and online, so Jeremy must know.
I don't know. I wouldn't presume. I don't think I can remember Jeremy coming in when we were doing it. To be honest.
It wasn't advertised, and Jeremy.
I think Jeremy just has a little bit less like in his voice. You know what I mean? So it's easier to talk to him.
Now, just a simple question, Jeremy. If you didn't compare your water level to a straight line, which was established in a different way than a level, did you prove anything?
How would you establish a straight line?
I have no idea what you just said.
That's on you. I'm asking Jeremy.
I don't know what you said. Was eating chips or something?
Bev compared his water level.
Hold on 1 second. Papers, please, not paper. Hold on, Chike. I gotta do some mod shit real quick, Chike. Papers, please, not paper. All right.
I didn't know I was on mute. I'll fix it.
Thank you.
So, Bev compared his level to his level. Did he prove anything?
Straight line. I don't know what Bev did. I don't know what Bev did.
Well, he can tell us if he wants. He can tell us if he wants to. But he won't tell us. I don't know why. Because it was online and advertised.
Because you guys get triggered when we start talking about it. As soon as we mention it might be a straight line proof, you get fucking triggered.
I'm asking you to talk about
What does
it.
triggered mean to you, dude?
It means
like a change in voice.
It means
tell us what you did.
It means that
because
you
you're the only one
guys.
with the change in voice
It
right
means.
now. You're the only one
It
raising his
means.
voice.
Right. It means that you guys don't know what the test is. And that's because you've never heard it. You keep talking over it like this.
So that's what triggered means? So you guys are so triggered right now because you don't know what's in my bedroom.
Yeah.
This doesn't make sense. That's not what triggered means, dude. Triggered means you're upset.
The fact that you can't let us finish and you don't know what the test is, that shows.
I'm just pointing out your antagonistic language. That's all I'm doing. You're antagonizing
can you
people
stop argue with
I would never stop anything for you, dude. I would never ever stop anything for you. Just for you. I would never do it.
Yeah,
just
it's
for
on
you.
you, babe. You want to
Never,
talk about your
ever stop anything just for you, buddy.
Yeah, right.
Never, ever.
Where is moderation when you
never
need
stop?
it?
Don't stop. Can't stop.
Wow, you're funny.
Can't stop. Won't stop. Pretty soon you'll learn, dog. You're pretty soon. Let's hope.
Yeah, you'll learn too. Don't
Never
worry.
stop. Wrecked him. Damn near killed him.
Yeah, laugh of your own stupid jokes.
Tell him about your bendy's onto.
No, tell us about your test.
Why do they use rectilinear lenses, by the way? Because they like to wreck the arguments from the flat Earth side.
How did I know that was coming?
I thought it was going to be an
just like I am.
Jeremy, I asked you a simple question. You compare the level line. You didn't compare the level line to a straight line that was.
How do you know what he did?
Did I tell you what he did?
You're telling me he didn't do this thing.
I didn't know.
How do you know?
I'm asking you a question. If you compare,
I don't know what he did either.
If you don't compare the level line to a straight line that was established in a different method, did you do anything?
So I don't know what Bev did or didn't do with his test.
I didn't ask you what
I wasn't
Bev
watching
did.
it. I should be hanging out with Bev more honestly. But
I'm asking you a question.
Stop muting me.
A theoretical question. Answer it there, Jeremy. It's a yes or no.
Hey, Jeremy, I want to say something. Jeremy, it's interesting. Normally I would not even lean towards Bev on this idea, but Chaiki makes it to where I want Bev to win this argument so bad.
Yeah, you can
hear that, Chaiki? You hear that?
You can help him.
You're
You
the
can
best
help
flat
him,
earther
You
here,
can say yes.
Chaiki.
You can say yes to my answer. Go ahead, help him.
You see how annoying you are, Chaiki? Even guys from your own side
I'm
tell you.
asking a question, can get a straight answer.
Him, dude. Most of us can't
For
stand
some
him.
reason, from Jeremy. What holds you, Jeremy?
sorry, I can understand like every fourth word you say, so it's making it very difficult. So say it again slow.
Slow, very slow.
Pretend like you are a baller, Jeremy, and just make something up you don't know anything about.
Very slow, so Jeremy can understand. So if you don't compare the level line to a straight line that was established in a different method other than using a level, did you prove anything, Jeremy?
Well, I mean, it would depend on what he did, which I don't know because you won't.
Was I talking about Bev, Jeremy? Did I say what he did or he did not?
It depends on what anybody
talking
on Earth.
about the proof.
Yeah, that's fine. It would depend on what the person did.
I told you what
personally,
he did.
I would like a horizontal line.
I told you what he did. Did
You
not
didn't tell me what he. You told me you don't know what he did. You
Did
told me you
not
don't know what he
compare-
did. Now you're telling me what he didn't do.
Did not compare the level line to a straight line that was established by using a different method other than level, Jeremy.
He must have done something else then.
I don't know. He will tell us what he did.
Do you want me to do? Do you want to give you a quick geometric recap? Like, it won't take long.
Yeah, that would be
It's really quick. It's really quick and really simple. Providing I get to say it.
Establish a straight line.
Oh, right.
Quiet, Chai, quiet.
Yeah, please.
I
Right.
muted him.
Quiet.
So a straight line is defined as the shortest distance between 2 points. Thus, if you establish that all of the other points lie along that straight line, you show that you have a shared straight line segment and all of the points are on the same straight line. Simply use that principle and overlap a water level. It's very easy. You show that all of the points at the center part where they are all joined are the same level, so they are on the same line. All of the points are together, showing a shared straight line segment.
So. All you've shown is that they're on the same level line, not the same straight line. That's the whole problem.
But it's a geometric proof for a shared straight line segment, just it is, George.
In the geometric proof is incorrect. That's
that actually isn't a geometric proof.
Where do you establish straight line?
The shortest distance between 2 points.
Yeah, but you didn't do it, did you? Yeah.
Yes, it is.
Well, you can't have a hump being the shortest distance between 2 points, can you?
Oh, we fucking know that, Bev. You don't need to repeat it.
Okay. Well, that's it done then, right?
But points on a level line on the water level are not necessarily the shortest distance. They lie on a level. They lie in equal heights, equal elevations. But
I agree.
That's not necessarily shortest distance.
Measured as a change in the vertical, right? That's how we measure. That's how we measure elevation changes. This has been
explained to you so many times.
I know.
It's really amazing that you don't accept that.
I wonder how this argument works, because it's assuming that it's a straight line and then proving it's a straight line by assuming that it's a straight line.
No. It's a straight line between
that's a beautiful argument.
Between each point on the level, there is a straight line. How do you prove that all the straight lines are on the same shared line segment?
Well, what's going on here, Shai? Because this is just like having two long, say, 2x4s, and you're trying to prove that one is straight.
There's nothing like using 4x2s, mate. Nothing like it.
Yeah. Well, this is like what Bev is basically
in George's imagination. I've got to imagine here now, right? Not.
Yeah, it's obvious like using.
What Bev is essentially doing here is proving that a curved 2x4 is straight by comparing it to another curved.
It's got fuck all to do with a 4x2,
well,
mate.
no, it would work with the two curves, right? You wouldn't be able to join them up together, would you, George? Because you would just make a curved line. You wouldn't. Yeah, but all of those points at the middle.
If it's the same curve with both poles, they'll line up.
And you attach a water level to that, George, and see if you can get the water level to do that too.
You could use two hula hoops, compare them to each other, and because they look the same,
affix a water level to it. Affix a water level to it.
You're saying a hula hoop.
Go ahead and do
it. Is straight.
Go ahead and do it.
What happens?
I can do it.
Overlap.
Go ahead.
Go on.
Yeah, overlap hula hoops.
Yeah, go on. Go on. I could, by the way, prove that the hula hoop is straight, so there you go.
Well, again, what Bev has done is saying, look, this
Done it with a tool that establishes a horizontal.
Because I've compared it to this other 2x4, and they coincide with one another.
No. The tool, a water level, is a tool for establishing a horizontal plane. We just proven it. Just proving it.
Oh my God! Why do we talk to these fucking trolls?
I don't know.
Why do we even have these conversations?
This is
with
ridiculous,
these
isn't it?
Fucking idiots! You guys are
Well, I
fucking
come in here
idiots.
just to experience it and see what I've heard a lot about these places, but I thought I'd just try it out and see what it is like. And yeah, I mean, if you can't figure out that from one point of a water level to the other is a straight line, then I don't know.
Well, it isn't.
Yeah,
That's
like
the problem.
adjustment
That's
points.
Spot on. That is the issue here. That's the core of the issue. Is you need to establish that the 3 points on the auto level or on the water level line up. We say they do not. They follow
There's 3 points in the middle. Yeah, 3 points, in which 2.
Sorry, does a carpenter's level make a? Would you say a carpenter's level makes a straight line?
So spot on. You have to conduct that test. You have to conduct that test spot on to see multiple points on a water level line up. Bevin's never done that. All he's done is gone through this geometric gyration and come up with nonsense.
Listen, Jeremy, we went over this earlier today. A spirit level is not level across from
only in the center point.
Only in the center.
That's it. It's the only point. It's horizontal.
Yeah, what a load of shit that is. Although actually, I mean, if you've ever used a level, a 4 foot, 6 foot, 8 foot, you know that anywhere along that level is level. Now you can argue that it's a small scale, but
we know it's level.
Again, you're fooled into thinking that every point on that spirit level is level because the difference between the end and the middle is less than 1 microinch.
George, are you confusing horizontal and level again? It is level. The tool is a level, George. We say it establishes a horizontal. That's it.
It's called level because it does give you a fairly good level over that short distance.
It's horizontal.
Oh, get out, man. I've been using it for fucking centuries. Seriously.
I heard that's they got the base of the Great Pyramid to be flat. That's the story, anyways.
Jeremy, please let us just mute all these fucking trolls that are here.
We gotta leave some of them.
No, we don't. No, we don't. We need new ones. We need new ones.
You need those.
Yeah, let's have an echo chamber. Let's not have anyone else.
These are the cream of the crop. These are all you've got. There's no new ones.
Yeah, but this cream is turned. They're like curdled.
Well,
they're not fresh.
The new school are coming with horizontal at a point. It's here. Like George's old school, he's out of here. You can't have this ridiculous argument that he's got. You need a new argument.
They're so
These are the globe defenders right here on 8. This is them. This is it.
Yeah, that's all you can talk about. I don't know why you don't answer my question, Jeremy. Straight up, say yes or no. Because I know you don't. You know the difference between the level and the code, right? You know the difference. At least what we argue about.
In reality, there is no difference.
I want to check reality. Bev refuses.
What? What?
Bev, why are you refusing to check reality?
Yeah. Like, you must be right. Like, I mean, what is it checking reality that needs to be checked?
Why are you not answering the question then?
Bev isn't accepting reality. What?
Whoa, Bev. What's up with this?
Say what?
I think Bev just got owned.
Yeah, so making tea, dude.
Yeah, returning to the hula hoops, I could actually prove that they are indeed level.
And straight.
You do you.
Using all the proper tools.
Do it.
Yeah, go on.
I can do it. It's actually sort of trivial to do it because it's easy to visualize.
Or is it like preparation needed?
Yeah, sure.
Sweet.
If you want to watch me you show how hula hoops are level? Sure.
Are you hula hooping?
Yeah, sure.
Sweet.
If you want to watch me, you show how hula hoops are level. Sure.
Are you hula hooping?
Yeah, sure.
Sweet.
If you want to watch me, you show how hula hoops are level. Sure.
Are you hula hooping? Please be hula hooping.
I'm just chilling out.
Papers, please. Have you ever held a water level?
$1 watch L'Oreal hula hoop.
Papers,
Sorry?
please. Have you ever used a water level? You ever held one?
Yeah, I've never held one.
No, I just wondered. I just didn't know if you had or not. Because if you
Of course I've held one. It's a stupid question. Everyone's held one.
No, not everyone. No.
No. Yeah, sure.
You think everyone's held a water level?
I have held one. So what?
Oh, okay, that's fair enough. Yeah, so you have held one. That's fine. Right. Okay. So when you held it up, when they equalised, yeah, did you see the water level in the actual tube, or was they in a hose pipe or something? Could you see the water in the tube? Yeah. Could you see the water in the water level tube? Do you know what the water level is? Sorry, that's all. Yeah, we're talking about.
Listen, you're talking.
Can you give me a short definition? Because
you're talking to a troll right now. He's not going to answer you.
No.
Oh, no. Is he? Oh, sorry, I didn't know.
Why are you white knighting, sir?
I'm not white knighting. I'm pointing out the fact.
You are.
You're
white knighting.
You're a fucking troll. You're not going to answer the question directly. You're a fucking troll.
No, trolls are
don't
those
ask
who...
him anything
Oh,
yet.
let another go. Go on, so you've held a water level, the tool, a bit of pipe, preferably see-through, and there's water in it. Yeah?
He's not going to give you a direct answer, bro, man. This is a waste of time.
like Jeremy didn't give me. Jeremy,
obviously there is water. Obviously there is water in a water level, and obviously you will see it when you hold it.
This is why
what the fuck?
we're doing away with these.
Right, hold on then.
Why is this the same question?
You hold them up and they equalise, yeah. So that's like a line between the two, yeah. Even if it's just in front of you, you can see that, yeah. You've done that, right? So if you lowered one, lower than the other one, what happens to the water?
So the water don't go up.
the bubble goes up.
Yeah, the water. That's why they don't go up.
Yeah, the water go down, the bubble go up. Go boom boom.
The bubble?
Yeah,
You're talking about a spirit level, aren't you?
Nah, go ahead.
See, these are the cream of the crop, spot on.
Yeah.
Telling you.
Go ahead.
Yeah,
Go ahead,
yeah,
left
I
lane.
get it.
You take a
That's
stab
fair
left
enough.
lane. You take a stab left lane. Go ahead. That's right.
No. Look, listen. If you've got two, you're one on your right, one on your left hand, and they're beside each other. They've equalised, and say there's an inch of tube above the water line. That'll make it easy. An inch, or if you maybe 25 millimeters. So if you were to lower one side, let's fix one side. There you go. That's fixed. That can't move. And you lower one side. What happens to it with the water?
What goes up in the tube?
I give up.
He goes, where? What?
Yeah, the water level will go above. You've got a reference, right?
Somebody's hot mic. And if you drop it below the water level, the water
I think you're hot
level will
mic.
run out of it. So what do you give up? I've used the water level quite a bit.
It
So
just equalises, Howard. Just equalises.
Well, you could say that.
Why didn't you?
Well, if you drop the tube below the water level in the other tube, the water will run out of that tube, right?
Until it equalises.
Until it equalizes. And then it'll cause the water level in the other tube to drop.
Equalise.
Yeah. So what, man? You're just being semantic.
That's how the tool works. You mean using words to explain how the water level works? Yeah.
It's to explain what you're seeing.
Equalize. Hydrostatic pressure.
Yeah, hydrostatic pressure. It's equipotential, right?
Neither higher nor lower.
So what's your point?
Well,
what's your point?
The higher or lower is measured on the vertical. Right?
So what's your point?
So the equal elevation is measured on a vertical datum. So that means 0 on the vertical datum. Do you know what they call that?
What do you mean 0 on the vertical
all
datum?
points perpendicular, horizontal.
Yeah, all that's meaningless to me, Bill.
Obviously. But a 0 vertical datum is a horizontal, because at all points along that, it is perpendicular to the vertical.
In order for me to use the water level in the manners that I have, it's simply a reference to an elevation so that you can get all of your points of interest at the same elevation.
Yeah, horizontal.
Yeah, exactly. A 0 vertical change. No change on the water level on the vertical.
Yeah, so what's your point? I don't understand.
That's
what
a
does that
horizontal plane.
So how is that useful? How is that useful?
It's a tool called a level. It's very useful. Trust me.
Yeah, I know it's useful. I've used it to, you could set up a deck, corner of the house, keep it all the same.
Howard, 1 point.
Uh-oh. That's pretty
Robot,
bad.
Travis.
Yeah, that's pretty bad.
Robot. And gone.
So you've used it, Howard. How far could you extend that horizontal using a water level, do you think?
I never went over 80 feet.
Yeah, no. How far do you think you could go?
He said, do you think?
That's pretty bad. Robot.
Mm-hmm. Yeah, he said, do you think, Howard? Think.
Oh, you could go as far as you wanted to, unless you were on a curved surface.
Oh. So how far, if you imagine you're on a curved surface, do you think you could go with a water level and establish a horizontal plane of reference with it?
With the I take that back. You could go as far as you wanted to on the surface.
Yeah. Go on.
Yeah, you could go as far as you wanted to on the surface of the Earth. Of course, it's not practical, and it really has no utility to say that, because who's going to use a water level more than 80 feet?
To establish floods, floodplains, and all of that sort of stuff. Yeah, it's vital, really.
Floods? What? Plains? What?
Yeah. Have you never heard of a floodplain?
Yeah, I've actually set up terraced a field when I was in college. That was my survey project, was to terrace a field so that it would hold water.
So you know what a plane is then, right? It's a two-dimensional surface, right? Two-dimensional, as in just length and breadth.
Yeah, it's kind of like the surface. Yeah.
Yeah. Like a plane.
Yeah. We didn't speak in terms of planes. We just wanted the terrace to be at equal elevation.
I'm just talking about when we say about floodplains, though, over vast distances. Some of them are massive. I think the Nile has a floodplain that's hundreds of square miles. And, Louisiana has a bit of a floodplain. They had to build Ligo above it, didn't they, to make sure? 500-year floodplain.
If you used a water level to establish this terrace of field, so to speak, and so it would hold water, and you set up multiple points across, say, 1,000 feet, and you sighted a line from your first point to your last point, what would the middle points look like?
Sighted? You're using a water level, aren't you?
No, but you took an instrument and sighted a chord line.
They've got a water level as a level. The water level's doing the job in it.
You're going to avoid. You're not going to answer the question, are you?
I'm just asking why. Like, you've got a water level, right? You've laid your plane out, all of the points, with the water level, right? To establish that there's no deviation in elevation. It's not, the water's not going to spill out of one corner. You've made it exact, right? Then what do you want to check with the thing? I mean, what's the point?
Bev, maybe he needs to buy a, hold on, Offline. Maybe he needs to buy one of those, what's those, Dark Shark thingies?
Well, that's what I'm checking now. Like, what is it that you're expecting? A drop?
Yeah,
or a hump?
What I would expect if I sighted from the first point to the last point, I would expect the middle to be higher than that.
So you wouldn't be able to sight the last point. When you say that, you'd be saying, when I sight from the first point to, where is it? Well, is it in the middle that I'd be able to? No, wait a minute, because there's a hump in between me and the middle. Like, you'd be coming back to an infinite point from where you started. The regression that you'd have to make mathematically to make that statement, Howard, is ridiculous.
No, it doesn't. The hump is not a hill, dude.
How can you see the end point if there is a hump in the middle? How can you possibly say, if I'm citing the end point from the first point, there's a hump?
So you're expecting to see something that we don't expect even in our own model to see.
How can you see the far distance point?
Straw man on our model, right?
Affirmative.
I'll let you think about that for a minute.
Are you serious?
No. The fact that we're pointing out your inconsistencies doesn't mean that we're the ones with the shortcoming in our intelligence.
I said over 1,000 feet.
Look, I really wasn't trying to say all that, dude.
Yeah, there would be no hump that would appear your view.
Yeah, it's just a mistake. Would there be a drop on that intelligence necessarily? So I'm not trying to be rude at all, dude. Don't think like that. That's the other fucking thing.
I'm not.
Left lane, would there be a drop if there's no hump?
Yeah, if you sighted the first point to the middle point, the last point would be dropped. Yes.
And
not humped.
And what, in a slope manner? Let's say A, B, C, right? We have 3 points. B in the middle. How do you envision it?
Like I said, if you sighted first to middle, the last point would be dropped from that line.
So you envision a slope from A to C.
Not a slope. Not a slope. No, that's not proper. A slope is a straight line.
How would you phrase it?
Horizontal.
A curve.
A curve from A to C. Okay. Yeah. While being level at the same time.
Yes.
Wow. Okay, that's some pretty fancy thinking there.
What's the definition of a curve, Howard? What's the definition of a curve?
It's not straight.
So this is some serious mental gymnastics. We got point A, B, and C that are straight.
It's not mental gymnastics, Issy. It's really not.
Yes, it really is.
Look for
yes, it really is.
Can I explain something real quick to Montreal? I think the real issue is, and I know that's because you guys don't like that language either, but the reason they're talking about it being the rises in elevation. First of all, there's a sphere, right? And then any bumps on the sphere would be a rise in elevation, but the sphere itself. You see a hump in the sphere. That's not a rise in elevation. All that stuff that we're talking about in that isn't a rise in elevation.
Okay,
it's just the model of the sphere.
Yeah. We get that. Right. We get that. But that's your redefining reality, just like a horizontal point now exists in your world. Or
you just made that
up. What did I make up? Hold on. What did I just
We're redefining reality. You made that up. I mean, how do you know that?
No. Okay, listen, I understand that you feel that way, but
it's not about a feeling for me. I don't care about feelings because I like all of you guys pretty much. I mean, I don't have any feelings like negative towards the ideas or anything.
Okay,
the only time I get rude with people or have feelings is when they're rude to me. That's it.
Don't threaten the model.
Right. Please. Hold on. Listen. Okay, so in our world, we only have elevation and distance. We only have deviation higher or lower. Okay. So we don't ever have to account for curvature, ever, unless someone created a graded hill that has curvature. And in that instance, there would be elevation. Now, in your world, you eliminate that point of discussion to say, oh no, on a ball, on a curved earth, there is no elevation. You've completely removed something that all of us know and understand in our experience as reality. There is no curvature, so
we don't say there's no elevation.
Excuse me?
There's plenty of, we don't say that there's no elevation. I don't understand where you're coming from.
Okay. So how do you differentiate between elevation over topography and elevation on a curve?
Sea level.
That's how we do it, and we only have one elevation. It's higher or lower.
Right, but then it's like a microbe on a basketball. He doesn't see the sphere. He sees a fucking flat plane all the way across in 360 degrees.
Yeah,
that's a flat plane.
Yeah, that's
true though. You know that. You can take a smaller field of view. Yeah, but it's a good analogy because it shows exactly reality.
Listen,
right?
do you know when I heard...
Hold on, let me explain something real quick before you go on. It only take me just a couple of seconds. If you're on a ball and you're really small, right, and you look around on that ball, there's videos of this where they take a little camera on a big ball and they flash all the way around. It's a flat line. You see a straight line all the way around you. Looks like a horizon, flat horizon. It's a ring around the ball. You're on the top, but the ball looks flat. But we all know it's a ball because we can get away from it and look at it. So until you can say, well, I mean, you know what I mean? Like, we're sure that that's not happening, then all this other stuff is like not true.
No. Again, listen. I first heard that analogy when I was a young child in school. Okay, so I was already pre-programmed to have that argument in my back pocket. If I ever came across a flat earther, I would have done the exact same thing as you just did. Okay, now the problem with that analogy is, what the fuck are you doing talking about looking at a basketball like an ant when we're talking about the earth?
Because the earth is much bigger than the human.
Yeah, I agree.
So it makes sense to talk about it in that aspect, doesn't it?
No, it doesn't.
Especially when we can receive the same results. That's what I'm talking about, bro. We can see the same results. When a flat earther says, look outside, the horizon is flat. I look all the way around me in 360 degrees and I see a flat horizon. Well, that's exactly what you would expect to see on a globe.
On a globe? What are you talking about? Wait, globe?
That's exactly what you would expect to see on a globe.
Globe? Wait a minute. I thought we were just talking about elevation changes and distance on Earth. Right? I agree with you. The Earth is massive.
That's what I'm saying.
Okay, listen. I agree with you. The Earth is massive. Absolutely. But you're trying to bring up an analogy of a basketball when we're talking about the Earth. Why the fuck would you do that?
I don't know. Why don't you ever correct Dimmock when he says, pour water on a basketball and blah, blah, blah. He wants to use a basketball then, it's fine. But when I want to use a basketball, it's not fine.
Because that's called reductio ad absurdum. We're taking...
No, I'm actually using it in
a... Pretty sure, Grim, I was just talking. It's real quick.
You were.
That's called reductio ad absurdum, where we take your model and show the absurdity of it. So, so we step into your world every once in a while.
But you haven't done that. You're saying you've done it, and that's a postulating. It's a posturing. When you say you're doing stuff that you're not, like I'm beating your ass as you're getting your ass beat. You're not really beating my ass. You're doing something else. I know, but I'm using it as an analogy. I mean, you're saying that you've shown me some ridiculousness in my model. I'm standing here waiting to see that. You haven't.
Okay,
that's what I'm trying to say. You haven't shown us. You're saying that you're showing us ridiculousness. That's just antagonistic.
Okay, so that's fine. Let's go back to the elevation issue, right? In our world, we only have that issue of higher or lower elevation. We never, ever talk about curvature.
I mean, because I'm sure we aren't, the world doesn't consist of just me and you.
Fine. Okay, if you're going to nitpick,
No, no, because there's people in other professions that do, right?
Okay, Grim.
You have to imagine that they're lying in order for your worldview to be correct. So all of these people in astrophysics and all of these people, astronauts, and all of the, they all have to be lying in order for your worldview to be correct, and that's what I'm talking about.
Okay, Grim. Now you're just muddying the waters because I'm not talking about anybody in any field who could be a baller. I'm talking about we who do not believe the Earth is a sphere. We who do not believe the Earth is a sphere, when we talk about measuring the Earth, we are only talking about elevation
That's not useful,
changes.
Sorry, that's not useful. Because
Okay,
I mean,
hold
it's
on.
like saying because I I don't deliver pizzas.
Yeah, go
because
ahead.
I don't deliver pizzas. No one delivers pizzas.
If you're just going to be illogical and make fallacies in your arguments,
That's what you're doing. I'm trying to point it out.
Okay, listen to me very carefully because
you're saying just because you don't work with astronaut shit, then there are no astronauts.
I wasn't finished again. Okay, because you made a nitpick about my choice of a pronoun, okay, which wasted time in our discussion. I now have to be a little bit more punctuated, and now you're still picking that apart. Okay?
Can I ask you guys a clarifying question, which I think will help the situation out here?
Sure.
Can I ask both of you a clarifying question?
Certainly.
Yeah, sure. Go ahead.
Okay, Travis and Grimm, the question is this. Can we have a drop or a hump without having elevation change?
No.
How about
On
you,
a sphere,
Grimm?
yes. On a sphere, yes.
See, this is where the disconnect comes in. Go ahead, guys.
No, exactly. That's what I was trying to point out earlier. That on a sphere, we're not saying that the hump is rise in elevation. That's literally the first sentence I came out with.
Yeah, but how can that be, Grimm?
Well, because because of the gravity of the situation.
You're not going to bring G in here, are you now?
No. What I'm saying is, well, that's what we're using, right? We're using gravity, bubble levels, what makes things go down and up, right? So we're using gravity in every single aspect of what we're trying to explain as flat earthers. When I say we, you guys are using it because you're using. I mean, Bev is using a bubble level, a water level, right? It's all gravity right there.
Dude,
Nothing
do you
about
not
that doesn't say
know
gravity.
what a water level is yet? That'd
course
be
I do.
pretty
Well,
embarrassing.
remember-
Why did you call it a
Bev,
bubble level?
It should be both bubble levels, plumb bobs, fucking water levels. They all deal with gravity, dude. Name a level that doesn't deal with gravity, other than a laser. Thank you. That's what I'm saying. So
you got to set a laser up with a level too.
Yeah, you do
Grim,
have to
can I
use
disagree
gravity
with you?
for a laser too to get it straight. So the whole point of what I'm saying is that thing that you're using to say that it's flat, well, we're using it too to say that it's
Which is
round.
horizontal. That's what we say.
Yeah, and we say the horizontal is a tangent to the sphere. So I mean, the definitions are right there, and it's not like
hold on, just real
it's
quick.
not like
Okay, listen.
any of those definitions are wrong. Yours are
sphere,
right,
again,
and ours are right.
Grim, a sphere doesn't have a horizontal anything.
Well, that's what you think. Yeah.
No, again, okay, so now we're back to the fact that you, Grim, are now changing reality. Okay? Show me a horizontal on a sphere. That is the sphere. Show me a horizontal on a sphere. Go.
Well, I'll shrink the lines small enough to where you can't see the curve. How about that?
Okay, anybody else want to not
That's how you do it.
Obfuscate?
That's not obfuscation. It's a complete answer.
Okay, take a sphere that you cannot alter its size or anything and show me horizontal on it, please.
Okay, shrink yourself down until the lines look straight.
Fuck you. Fuck off.
Well, you said I couldn't shrink the sphere. You're not winning this way, bro. I'm trying to let you know that when I draw a straight line, what I look like is straight. I draw it on a paper. Look, I can use a ruler to draw a straight line, but then I magnify. Excuse me for a second. I magnify that line, and I find out that line's not straight at all.
Have you ever noticed you always have to go to imagination land, Grim? Have you noticed that?
Is drawing a paper, is drawing a pencil, and on a
shrinking ourselves down. That's imagination land.
Really, drawing a straight line on a piece of paper, and then magnifying it till you see that it's not actually a straight line. Or draw a curved line on a piece of paper, magnify it down to where it looks like a straight line. You're roboting. That's what I'm saying. You're acting like show me on a sphere. He's roboting.
Again,
I don't know when to
you
start.
are obfuscating. You are obfuscating. You are obfuscating.
Well, you gotta quit using that word when it's not really doesn't apply. You're just using it because you think it's a smart word to use.
Okay,
Everybody's using that word now. It's weird. It's a trend.
Okay. Again, Grim. Just be honest, bro. Let's talk about spheres.
Don't ask somebody who's always being honest to be honest, because it's implying that they're not. All right.
No, you're not being honest. You're not. You're not being honest
about, dude?
Stop using a reference to imagination by shrinking one object or another. Okay?
Okay, well then stop trying to get me to use objects that are way smaller than the Earth to prove a point.
So you cannot show me.
You're doing it. You're shrinking things down. You are.
No.
And then you're telling me not to do it.
Okay.
Show me on a ball, you said. Show me on a ball. Is that the Earth? Is that a big enough ball? No, it's a small fucking little piece of shit fucking ball, right?
Okay.
So then you're going to complain about me doing the same thing and saying, okay, well, then let's scale it properly and look at it, is all I'm saying. Let's scale it properly. This is basically what I'm trying to tell you. And you're very adamantly against scaling. That's strange. That should be dishonest. I should ask you, why don't you be honest? Why can't we scale it? Because scaling would end your argument. I got to go, man.
Yeah, thanks. Please do go. Howard, would you like to step up?
I'll drop the mic before I leave. Boom.
Was he on about scaling a straight line? Or what was he scaling? Was it a straight line that he was scaling?
Yeah, he says if you scale it, it curves.
Right, if you scale a straight line, it curves.
If I got him right, yeah.
If you scale a curved line, if you go down small enough on a curved line, you'll find straight spots. That was his claim.
Well, that seems a little bit ridiculous, right?
That's what we see, right?
The surface of a sphere is a surface of constant curvature, right? If it's there, it would be there to be measured. Because we can surely tell the difference between a curve and a straight.
Is a curve not just made of straight line segments?
Wow.
Travis, you're breaking up so bad we can't understand you, brother.
Again.
No. You fucks. I said, no, it's not, you fuck.
Okay. I mean...
Right, so we all know that if you start off with a curved line, it will make a circle, right? We know that. That's not something that's new to us. We're just saying it's a straight line. It doesn't curve, right? That's what it shows us. It's a straight line. We have geometric proofs to show us that. We have logical proofs to back that. We have practical proofs to back both of them.
And we have measurements that show a level line is not straight.
Yeah, we're still waiting on your measurements there, Bev. We still haven't seen them.
The measurements to show that a shared straight line segment.
Yeah, we're still waiting on your measurements, actually. Not pictures of you manipulating some tube.
Do you want to do it for yourself?
Is this the guy that uses an auto level for 16-mile observation? Talking to you, Bev.
I think so. I don't think he's got a measuring rod.
Oh, he uses the building. Yeah.
That's what I've heard from everybody else.
Oh, he uses a building that's affected by refraction at 13 miles?
16 miles. Yes, sir, Travis.
As his measuring rod. And he doesn't even put pattern flashing lights on it.
Yeah, actually, that shoreline is only 13 miles away, so it's not even 16 miles.
Yeah, the problem is I can't see the shoreline ever.
That's not a problem, B-Brick.
And that's due to the hump, bro. B-Ball, that's due to the hump.
It's definitely a problem for you guys.
B-Ball, answer my question. Is that due to the hump of the Earth?
It's due to the drop.
Yeah. Whatever you want to call
The
it.
drop.
Whatever you want to call it.
So let me get this straight. Okay.
Water blocking it. Yeah. Whatever you want to call it.
Okay, some clarity.
You've been confusing yourself with this for a long time, so I don't know what to tell you.
Okay, I'm confused. Some clarity, please, then, if you don't mind.
You don't want clarity. You want to keep asking the same question.
Yes, this is a different question, I assure you.
Oh, this is from B-Brick. Oh, that's rich.
Are you afraid of my question, Bibo?
Yes. No, I'm not afraid of your question. No.
Okay, then, from your.
Yeah, you've been
where
asking
you're
the
at
same
to
question
where.
to every.
You're not gonna let me get it out, are you?
What difference is it gonna be when I answer your question? Are you gonna stop asking it? Or are you gonna continue?
It depends on the answer. It depends what answer you give me. How could you expect me to know that?
Because I know you. You're gonna keep asking the same question. As if the result of it is it a hump or a drop? Whichever one you want.
Keep quiet for 30 seconds and you'll know my question, please. The question is from where you're at, where you're observing, to where you say that drop is. What is the water doing to that 13-mile location?
It's dropping away. It's dropping away.
It's dropping away at a certain angle, but when it gets there, it really goes down. The angle changes.
I've answered your question. So will you stop asking it?
What, are you afraid to have a conversation about your observation that you keep bringing up?
I just answered your question.
Okay, and I have a follow-up.
Oh no, I have a follow-up now.
Go ahead.
So have you figured out the difference between a solar eclipse and a new moon?
Why are you changing the subject?
Because I answered
on track, B-ball.
I never claimed it was an eclipse. Now listen up. Now, from your destination, right, where you said it drops till that drop, right? There is a big difference, right? Like, is there like an angle of let's?
It shouldn't be dropping
Yo,
at all.
stop muttering through him. B-ball, relax, bro. Relax. Take a deep breath.
Why are you freaking out, bro?
Take a deep breath, bro. Relax.
Why does he get to ask questions and I don't? How is what's
I answered your question. You asked me new moon eclipse, and I told you no, that's not what I said. Now it's my turn.
His questions are really funny.
Yeah, they're really dumb.
Now it's my turn. You're a chicken shit, man. You're just a chicken shit.
B-ball, do I gotta mute you when he talks so that he can get his whole sentence out, or what? SE's acting completely civilized and he's cool, calm, and collective right now, and you're spiraling.
Thank you. Now maybe I can get my question out. He says that from where he's at, there's a continuing slope. And then he says where it really shows the hump, it's not a hump, but it's a drop. It's a curve. So what my question is there a difference in the level of from his eye to where that curved drop is? Because it goes really down after that. That's my question.
Oh, am I unmuted now? That's nice. Thank you. Appreciate it.
I didn't mute you.
Yeah, you did. I did get muted.
Oh, it wasn't me.
Yeah, I did.
Did you hear the question?
It wasn't unwarranted, though, because you were spiraling a little.
B-ball, did you hear the question?
Yes, I heard the question. It's the same exact question you always ask.
It's not. It's a two-part question.
Water drops away. That's my answer. And
yeah,
for
but
some reason,
there seems to be two different levels of drop.
Wait, can you let me talk now? Even though it's supposed to be flat, for some reason it appears that the water is blocking everything behind it.
That's your answer? Are you done?
Yes.
That's really not an answer, because it appears in your picture that there's water and it's almost level till it reaches a certain point. We'll call it a hump. You call it a drop. And then the angle changes dramatically, like as if I can put a surfboard there and go surfing. So how do you explain that?
Because the water's curving. SE.
Only at that point? There's a dramatic curve there?
It's a squared function.
It's the same thing as if you were looking over, if you were you put your eye down over a ball or something, or a large exercise ball. There's a consistent curve, right? So you see the ball until the drop off. It's the same exact thing, SE.
Yeah, but when you're looking at a ball, you see a hump there. You see.
I don't know why this is so hard for you to understand. Put your eye down to a basketball or to any ball. You see the ball until you can't see it anymore when it starts to drop away from you.
But you see something with the train tracks.
Put an object on the other side where you can't see it anymore. Same thing is going on the Earth.
You're not addressing the question, B-Ball, but I understand.
Okay.
I won't bug you anymore, but I'm sure everybody listening understands what just happened.
Yeah.
Yeah, it proved that the Earth is curving.
Yeah, the drop is a square function.
And it only drops at 13 miles away, right? Right, left lane?
It's just the drop is a squared function. Yeah, 8 inches on the first mile, 32 on the second mile. What is it, 128 on the third mile?
It does appear to be
people's observation, left lane. We don't see that. And he just said that we don't see that.
It does appear to just be this optical effect happening and not actual.
Yeah, at 13 miles, right, Jeremy?
If you enjoyed the content, please support On the Level and future projects. Membership subscriptions available now, or come and get involved at Next Level Discord server. Thank you.